Anything surviving for more than a few million years is an extraordinary event. Let's put it into perspective. If something, anything, manages to survive more than a few million years on this planet, that's a miracle, a geological one. An exception so rare it borders on magic. Because remember, Earth doesn't like to keep things. It burns, it breaks, it buries, it recycles. This planet isn't designed to archive the past. It's built to move forward, to evolve, to constantly reshuffle the deck. So if you find something that's millions of years old, a fossil, a mineral, a structure, even just a chemical trace, you're looking at a survivor, a freak accident of preservation, a tiny sliver of time that somehow dodged every force trying to erase it. Most things don't make it. Most animals that ever lived, gone without a trace. Most plants, never fossilized. Most human artifacts will be dust in 10,000 years, if not sooner. Even our best-built things, bridges, monuments, tunnels, they're toddlers compared to Earth's timeline. In nature, she doesn't care how proud we are of them. Let's say you bury a city today, cover it in ash, Pompeii style. Now leave it alone for 10,000 years. It might survive. Some walls, some pottery, maybe a skeleton or two. But now take that same city and stretch the timeline to 10 million years. Game over. Rock layers build up. Pressure crushes everything. Minerals replace the bones. Ash becomes stone, and before long, even the outlines of what used to be there, gone. Not because it wasn't important, but because time doesn't care. So when we go searching for signs of ancient life, whether it's dinosaurs or some possible pre-human civilization, we have to understand the odds. The odds are brutal. Finding anything, even just a hint, means something extraordinary happened. Perfect conditions, just the right place, just the right timing. No floods, no fires, no earthquakes, no erosion. And that's rare, really rare. That's why scientists get so excited when they find a single fossilized tooth in a cliff face or a weird mineral pattern in a rock layer. Because that tiny thing, it shouldn't be here, but it is. It survived. It tells a story from a time we'll never see. And in a world built to forget, that's priceless. So if someone, something, had built a civilization millions of years ago and anything they created managed to survive until today, that wouldn't just be archaeology. That would be a miracle. A whisper through the noise, a fingerprint on a glacier, a voice from the deep past that refused to be erased.
What if we're not the first civilization on Earth? Okay, let's do something fun. I want you to pause, just for a second, and think about everything around you. The skyscrapers, the planes in the sky, the satellites floating above the planet right now. The internet, smartphones, nuclear power, artificial intelligence. This is our world. This is our age. This is what we call civilization. But here's the real question. What if this isn't the first time Earth has seen something like this? What if all of this, our roads, our cities, our science, has happened before? Not recently, not in recorded history, but millions, even hundreds of millions of years ago? And I'm not talking about Atlantis or ancient myths, not ancient aliens or pyramid conspiracies. I'm talking about a serious, scientific possibility that another intelligent species may have walked this Earth long before us, that they may have built their own world, reached their own heights, and then disappeared completely. Think about that for a moment. We assume we're the beginning. We act like everything started with us. But Earth has been spinning for 4.5 billion years. That's a lot of time. We, modern humans, have only been around for 200,000 years. Our civilization, 10,000 years. That's it. If Earth's history was a 1,000-page book, we'd be the last word on the last page. Everything before us? It's a mystery. And we like to believe that if someone had come before, we'd know. There'd be ruins, skulls, tools, something. But here's the catch. Earth doesn't keep souvenirs. This planet is alive. It shifts, it shakes, it buries and burns and crushes everything over time. After a few centuries, steel rusts. After a few millennia, concrete crumbles. Give it a few million years, and the land where your house stands could be the bottom of the ocean, could be a mountaintop, could be dust. So, if there had been another civilization, would we even know? Would we recognize the signs? Would we even think to look? Now let's flip this around. Imagine a future, millions of years from now. Humanity is long gone. The oceans have shifted. The continents have moved. New life has evolved. Maybe even new intelligence. Would they find us? Would they find the ruins of New York buried under rock and coral? Would they find silicon ships fossilized like trilobites? Would they know we were here? Or would they find nothing but a strange layer in the earth? A sudden spike in carbon, traces of plastic, a whisper of radiation. Would they wonder, what happened here? Would they ask, were we the first? Just like we're asking now. This isn't just about curiosity. It's about humility. We see ourselves as the crown of creation. But maybe we're just one chapter in a very, very long story. A story we barely understand. A story that started long before we showed up. And if that's true, if there was a civilization before us, what happened to them? Did they destroy themselves? Did the planet wipe them out? Did they leave? And here's the kicker. Are we heading for the same ending? So maybe the real question isn't just, what if we're not the first? Maybe it's, will we be the last?
We are not looking for ancient skyscrapers or smartphones, but more subtle traces. When we talk about the possibility of an ancient civilization, one that came long before us, most people picture something dramatic, like giant stone skyscrapers buried under the jungle, or ancient smartphones made of crystal tucked away in a hidden tomb, or some ancient version of New York City waiting to be uncovered beneath the Sahara. But that's not what we're looking for. Not really. Because the truth is, time doesn't work like that. Skyscrapers don't survive millions of years. Neither do highways, or laptops, or power grids. If a civilization existed 100 million years ago, it wouldn't leave behind intact cities. It would leave something else. Something smaller. Something subtler. Something stranger. So what are we looking for? We're looking for fingerprints. Not handprints in clay, but chemical fingerprints. Changes in the soil. Anomalies in rock layers. Weird patterns in the atmosphere. Things that say, hey, something unnatural happened here. Because civilizations, ours included, change the planet. We mine. We burn. We build. We leave behind chemicals, metals, radioactive elements, synthetic compounds that nature would never make on its own. We reshape ecosystems. We shift the balance of gases in the air. We dig up ancient carbon and throw it back into the sky. These are the real footprints of civilization. Not buildings, not tools, but chemistry. So if we want to find signs of a civilization that lived and died millions of years ago, we need to think differently. We don't go digging for old cities. We study sediment. We analyze carbon isotopes. We scan for plastics, heavy metals, radiation traces in layers of rock that have been undisturbed for eons. We ask weird questions like, why did carbon levels suddenly spike at this time? Why is there a thin layer of metal-rich clay from 56 million years ago? What's the strange polymer that doesn't match anything natural? That's the real detective work. That's the deep science. And yeah, it's hard. Because time is the ultimate eraser, and nature doesn't leave behind neat little labels. But subtle doesn't mean invisible. If something big happened, if something intelligent lived and changed the world, it may have left echoes. And those echoes, that's what we're chasing. Look, here's the thing. If we're expecting to find skyscrapers, we're going to be disappointed. But if we tune into the right signals, the story might still be there. It might be hidden in the rocks, in the ice, in the deepest layers of the earth. Not in stone tools, but in isotopes. Not in lost cities, but in chemistry. Not in artifacts, but in anomalies. Because civilization, true planet-shaping civilization, leaves a scar, even if the bones and buildings are long gone. So we're not looking for a lost iPhone. We're looking for what it did to the world around it. And in that way, we might just find that someone, long ago, made the same mark we're making now. Core challenge. Could traces of an advanced civilization survive millions of years of geological erosion? Let's get to the heart of it. The core challenge. The big question that keeps scientists up at night when they even dare to consider this idea. Could anything at all, survive millions of years of Earth doing its thing? Because Earth, she doesn't play nice. She's not a museum curator. She's not filing it away in neat drawers. She's more like a ruthless editor with the delete key stuck on repeat. Time on this planet isn't passive. It's aggressive. Think about what we're up against. Rain, wind, ice, heat. They wear everything down. In just a few hundred years, metal rusts away, stone cracks and crumbles, wood rots, glass turns back to sand. Give it a few thousand years, forests grow over ruins, rivers change course, cities sink, vanish, get swallowed up. Now stretch that out to 1,000,000 years, or 10, or 100. What's left? Not much. And that's just the surface. Now add in the real monsters of deep time. Earthquakes, volcanoes, continental drift, glaciers grinding everything beneath them. Entire oceans vanish, mountains rise and fall, land gets buried, recycled, and reborn. Even the seafloor itself, the literal crust under the ocean, gets pushed down into the Earth's mantle and melted. Over millions of years, Earth doesn't just erase things, it recycles them. It turns ruins into dust, dust into rock, and rock into magma. So the question isn't just, could traces survive? The real question is, where could they possibly hide? If an advanced civilization existed 100 million years ago, and let's say they were just as advanced as we are now, would there be any part of what they built still here? Maybe, but it wouldn't be obvious. No pyramids, no metal tools, no ancient laptops hiding in caves. You'd be lucky to find a layer, a sliver of sediment, a chemical fingerprint buried deep in the rock, a strange pattern in isotope ratios, a sudden jump in carbon, maybe even tiny spheres of synthetic material that don't belong. Tiny anomalies. That's all you'd get. Because the rest? Gone. So yeah, this is the core challenge. The odds are brutal. You're asking for something, anything, to survive the most destructive forces on this planet for tens of millions of years. And yet, if a civilization did rise before us, and it did alter the planet the way we're altering it now, then maybe, just maybe, some whisper of it remains. Not in plain sight, not in bones or bricks, but buried deep, encoded in the chemistry of the planet itself. And that's where the real hunt begins. Human history, a few thousand years, is just a blink compared to Earth's age. Let's zoom out for a second. Like really zoom out. We love to think of ourselves as ancient. We talk about the Romans, the Egyptians, the Babylonians like they were the dawn of time. But if you laid out all of Earth's history into a single calendar year, modern humans would show up on December 31st at about 11:59 p.m. And not even at the start of the minute, more like the last couple seconds. That's how new we are. All of human civilization, writing, farming, cities, empires, it's just a flicker, a blink, a breath. Earth is 4.5 billion years old. That's 4,500 million. Try saying it out loud. Try feeling how big that is. That's the kind of number that makes your brain hurt. Mountains have risen and disappeared before we ever existed. Oceans have formed, shifted, and dried up. Entire continents have crashed into each other, split apart, and danced across the globe. Even dinosaurs ruled this planet for 165 million years. We've only been writing things down for about 5,000. That's not even apples and oranges. That's more like comparing a mayfly to a mountain. So here's the punchline. If something happened 100 million years ago, not a natural disaster, not a comet or a volcano, but something intelligent, something civilized, would we even know? In the grand story of Earth, we are the newest paragraph on the last page. So it's not crazy to ask, could there have been other paragraphs that got erased? Because if we're just a blink in time, then what else has blinked long before us?
Tectonic activity. Earth's plates collide, pull apart, and slide past each other, creating earthquakes, mountains, and new ocean floors. Now, if you thought sedimentation was intense, wait until you meet its big, chaotic cousin, tectonic activity. This is the Earth's version of a construction crew, but the kind that doesn't ask for permission, doesn't follow safety codes, and definitely doesn't clean up after itself. Here's what's really going on beneath our feet. The Earth's crust isn't one solid shell. It's cracked into giant plates, like puzzle pieces floating on a sea of molten rock. And these plates, they move. Slowly, constantly, unstoppably. Sometimes they crash into each other. Sometimes they pull apart. Sometimes they slide past, grinding edge to edge. And every time they move, the world changes. Let's start with collisions. Two plates slam together. And what happens? Mountains. Big ones, like the Himalayas, formed when India crashed into Asia, and it's still pushing, still rising. But it's not just mountains that form. It's earthquakes. Because when pressure builds between plates and finally gives, it snaps violently, and the ground shakes. Entire cities crumble. Land lifts or sinks. Sometimes coastlines move by meters, in seconds. Now let's flip it. What happens when plates pull apart? New Earth. Literally. As they drift away, magma rises up from below, cools, hardens, and just like that, we get new ocean floor. It's happening right now, deep beneath the Atlantic Ocean, the mid-Atlantic ridge, where new crust is being born every day. It's wild to think about. The floor of the ocean, it's not ancient, it's fresh, geologically speaking. In fact, the oldest ocean crust is only about 200 million years old. That's nothing compared to the Earth's age. So if an advanced species had once walked this Earth 100 million years ago, and they built near a coastline, or on an island, or on a tectonic plate boundary, there's a good chance their entire civilization has been subducted, melted, crushed, or warped beyond anything we'd recognize. That's the brutal beauty of tectonics. It makes Earth dynamic, alive, ever-changing. But it also makes it incredibly good at hiding the past. Not because it's trying to, but because that's just how the planet works. So next time you feel a little earthquake, or hear about mountains forming over millions of years, or look at a map of the ocean floor, remember,
The surface of the Earth is temporary, and anything built on it, just passing through.
Time doesn't just pass, it acts. Burying, melting, crushing, shifting, and erasing. Here's something we don't say enough. Time isn't just passing by. It's not some quiet observer just sitting in the background. It doesn't just tick like a gentle clock on the wall. Time acts. It does things. It has force. It has power. It's the great sculptor, the ultimate editor, and sometimes the destroyer. Because here on Earth, time doesn't just leave footprints. It leaves scars. And sometimes it wipes the page clean. Time buries, layer after layer of dirt, dust, ash, sediment, falling, settling, piling up over years, centuries, millennia, until what was once on the surface, once visible, once alive, gets shoved deeper and deeper, lost under the weight of everything that came after. Time melts. Under the Earth's crust, heat is relentless. Nothing survives down there. Metal becomes liquid, stone becomes magma. Everything that was gone in a river of fire. Mountains sink. Cities, if they ever made it that far, wouldn't stand a chance. Once something's melted, it's rewritten. Not erased like a pencil, more like recycled into a brand new planet. Time crushes. With weight, with pressure, layer after layer builds up until even rock folds and bends. Fossils get warped, sediment turns to stone, structures, if they ever existed, are pulverized into unrecognizable bits. A skyscraper wouldn't turn into a ruin, it would turn into sand, or worse, become nothing at all. Time shifts. Continents drift like slow grinding tectonic puzzles. They crash into each other, rip apart, slide sideways. Rivers carve new paths through solid stone. Mountains rise. Oceans swallow coastlines and create new ones. If you built a city on the edge of a continent 100 million years ago, that place might now be at the bottom of the sea, or buried inside a mountain range, or long gone, subducted into the mantle and melted. Time erases. That's the final blow, the quietest, the most complete. It doesn't leave signs that say, this used to be something. It just moves on. And unless you're looking in exactly the right place, at exactly the right layer, you'd never even know something had been there at all. So yeah, time doesn't just pass, it acts. It grinds, it presses, it breaks things down. It rewrites the story again and again. It buries the truth under millions of years of noise. That's why if another civilization did exist millions of years ago, the question isn't just, did they leave anything behind? The question is, did anything survive the way time acts on this planet? Every few 100 million years, the face of the world changes completely. Here's a wild thought. Every few 100 million years, Earth gets a brand new face. Like a full makeover, a reset button, a complete transformation of everything we know as the world. And I'm not being poetic. This is literal, geological, real. The continents don't stay put. The oceans don't stay where they are. The climate, the coastlines, the mountains, the species, all of it changes. Sometimes slowly, sometimes violently, but always, inevitably. Picture Earth like a restless artist. It sketches something, then gets bored and starts again, wipes the canvas, flips it over, uses fire, water, ice, and pressure to create something new. You think the Sahara has always been a desert? It used to be a lush green jungle. You think Antarctica has always been a frozen wasteland? At one point, it was covered in forests. And the continents? They're not fixed. They're floating, slowly drifting on tectonic plates like icebergs on molten rock. There was a time when all land on Earth was one supercontinent, Pangaea. Then it broke apart, formed new oceans, new coastlines, new ecosystems. And it'll happen again, because Earth never stops moving. Every few 100 million years, the whole planet shifts. Mountains erode, new mountains rise, volcanoes create new islands, old ones sink beneath the sea. Oceans disappear, lakes dry up, rivers carve new paths through solid stone, forests become deserts, deserts become swamps, ice caps melt and then return. Species rise and go extinct, over and over again. So imagine this, if civilization had lived here, say 200 million years ago, the land they built on might not even exist anymore. It might have been swallowed by the sea, or pushed underground, or ground into dust by glaciers. And that's not fantasy, that's geology. Because the face of the Earth we know today, it's just one version, one temporary version. It's not permanent, it's not sacred, it's not safe. It's just the latest chapter in a story that keeps rewriting itself. That's the challenge. That's why we can't just go digging in the backyard and expect to find proof of some lost civilization, because the world they knew may no longer be part of this world. It may have been erased, not by conspiracy, not by time alone, but by the Earth itself. Because every few 100 million years, Earth looks in the mirror and decides, let's try something new.
Initial hypothesis. If an intelligent species evolved 100 million years ago, would we even know? So here's the big hypothetical, the kind of question that makes scientists lean back in their chairs and stare at the ceiling. What if an intelligent species evolved 100 million years ago? Not just smart animals, not just tool-using apes, but a real civilization, thinking, building, reshaping the planet, just like we are today. Would we even know? Would there be any trace of them left? Any proof they were here? Any hint that we weren't the first? Let's break it down. 100 million years ago, the world looked nothing like today. No humans, no mammals worth noting, just dinosaurs roaming across supercontinents. A humid, strange planet covered in forests, swamps, volcanoes. No polar ice caps. Sea levels were way higher. Different atmosphere, different chemistry, different life. Now imagine some species evolved in that world. Let's say they weren't like us. Maybe they didn't walk on two legs. Maybe they didn't talk the way we do. But they were smart. Civilization-level smart. They built things. They used energy. They altered ecosystems. Maybe even had cities, culture, science. And then they disappeared. Extinction. Climate collapse. Or maybe they left. Maybe they stayed until they couldn't anymore. The question is, would we know they ever existed? And the uncomfortable answer? We might not. We really might not. Because everything we just talked about, erosion, tectonic shifts, decay, times brutal editing, means that after 100 million years, almost nothing survives, unless they built something out of mountains or buried things deep underground in some stable, dry, low-oxygen cave. Their cities would be dust. Their tools would be rust. Their bones, if they even had bones, would have long dissolved. Their history, erased by time, edited out of the geological record.
So then the only chance we'd have is if they left behind something we weren't expecting. A chemical fingerprint, a global signal in the rock, a change in carbon ratios, a sudden layer filled with heavy metals or synthetic molecules. And even then, we'd have to recognize it. We'd have to be looking for it. We'd have to be open to the idea that maybe, just maybe, someone else figured it out long before we did. And that's the heart of the hypothesis. If they evolved, if they built, if they vanished, would we even know? Maybe not. And that's what makes the question so powerful, so haunting, so deeply worth asking. Because it doesn't just challenge our knowledge of the past. It challenges our assumptions about the present and our blind spots about the future.
Traces of prehistoric human activity are incredibly rare because Earth is an efficient recycler. Let's talk about deep history. Not the last few centuries, not ancient Rome, not Egypt, not even Mesopotamia. I'm talking prehistoric humans. Before writing, before farming, before cities. The earliest humans. The hunters, the wanderers, the first ones to strike fire or carve a tool. We know they existed. We're here because of them. But what did they leave behind? Almost nothing. And that's not because they didn't do anything. They hunted, they cooked, they carved tools, made clothes, painted caves, buried their dead. They built lives. They told stories. They lived. But Earth doesn't care. It's a ruthless recycler. Wood rots, bones dissolve, tools rust, footprints vanish. Anything left on the surface, wiped clean, soaked by rain, tumbled by wind, covered in dust, swallowed by time. Caves collapse, rivers flood, forests grow over everything. And layer by layer, all that activity, all that history gets buried, crumpled, erased, or rewritten by nature. Even when we do find something, a stone spearhead, a cave painting, a skeleton curled in ancient soil, it's rare, a fluke, a perfect storm of conditions that allowed just one thing to survive. And even then, it's fragile, faded, partial. We might find a tool, but not the hand that held it. A fire pit, but not the stories told around it, a bone, but not the voice that once spoke. So if our own prehistoric ancestors, just tens or hundreds of thousands of years ago, left so little for us to find, then what chance would we have of finding traces of a civilization that lived millions or even hundreds of millions of years ago? The truth, very little, because Earth is efficient. It recycles everything. It's not sentimental. It breaks down the old to make room for the new. And that includes us. So when people wonder, if someone came before, why can't we find them? Sometimes the most honest answer is, because the Earth already used their story to write a new one. The burden of proof for the existence of an ancient civilization is enormous. Let's get honest about something. The burden of proof for an ancient civilization, especially one from deep time, is massive, like enormous. It's not enough to say, well, maybe they were here, or wouldn't it be cool if someone came before us? Cool? Yeah, but science doesn't run on cool. It runs on evidence. And when you're talking about a civilization that may have lived tens or hundreds of millions of years ago, you're not just looking for a clue. You're looking for a needle in a haystack where the haystack has been set on fire, buried under a mountain, and recycled into lava. That's how tough this is. Because to prove that a civilization once existed, we don't just need hints. We need something undeniable. Something that says, someone was here. They were smart, they were building, and they changed the planet in a way that couldn't happen naturally. But here's the catch.
Most of what a civilization makes doesn't last. And what does last, it gets buried, crushed, melted, or erased by the Earth itself. Even our most advanced materials, our steel, our plastic, our concrete, won't survive forever. Give it long enough, and it's all just dust. So the few things that might survive, chemical signatures, strange isotopes, deep underground structures, even those are rare and hard to interpret. Because nature's not clean. It's messy. A weird chemical spike in the rock could be industry, could also be a volcano. A sudden extinction event, maybe someone burned too much carbon, or maybe an asteroid hit. Unusual metals in a layer of sediment, civilization, or just an ancient mineral-rich ocean current. It's not just about finding something strange, it's about ruling out every natural explanation first. And that's what makes this burden of proof so heavy. The deeper in time you go, the harder it is to separate signal from noise. And if we're going to claim someone came before us, long before us, we better be absolutely sure. Because that kind of discovery wouldn't just rewrite history, it would rewrite everything. Our place in time, our sense of progress, our assumptions about intelligence, evolution, even destiny. It would shake the foundation of how we see ourselves. So yeah, the burden is enormous. And maybe that's why we haven't found anything. Yet. Or maybe we've found hints but we're too cautious to call them what they might be. Or maybe, just maybe, the Earth really did wipe everything clean.
If ancient civilizations lived near coasts or on islands, their traces might be long gone. Let's talk location. Because when we imagine ancient civilizations, whether they're real, hypothetical, or just whispered about in legends, where do we picture them? By the water, near rivers, along coastlines, on islands. It makes sense, right? That's where civilizations tend to start, where there's food, fresh water, transportation, trade. Even today, most of humanity lives close to the ocean. So if a long-lost intelligent species once walked this earth, they probably built near water too. But here's the problem. Coasts don't stay put, and islands don't last forever. They shift, they erode, they sink. Storms tear through them, tides reshape them, tectonic plates swallow them. Over millions of years, entire coastlines move, sometimes hundreds of miles. Islands get subducted, flooded, or just plain washed away. Let's go even darker. Sea levels rise and fall. During ice ages, the oceans shrink, land bridges appear. Then later, those same areas are underwater again. A thriving coastal city could end up 100 meters below the surface. And the ocean? It's not gentle. Saltwater corrodes, waves smash, currents carry things away. Even if ruins once existed down there, they wouldn't survive long. Not in any recognizable form. And islands? They're even more fragile. Volcanic islands collapse. Coral atolls sink. Tectonic shifts pull land downward. If an advanced civilization once called an island home, there's a good chance that home is now part of the seafloor, or gone altogether. And the kicker? The ocean floor itself is constantly being recycled. So even if something managed to settle down there, it's only a matter of time before it's melted and erased. So when people ask, if someone came before us, where are the ruins? One possible answer is chillingly simple. They built near the sea, and the sea took them. It's not that they were careless. It's that the places that give life are also the first to take it back. And if their world vanished beneath the waves, there may be nothing left for us to find. Not because they were never there, but because Earth has a habit of hiding her past in places we can no longer reach.
Fossilization is an exception. Specific conditions are required: rapid burial, mineral replacement, protection from erosion. Here's a truth that surprises a lot of people. Fossilization isn't normal. It's not the default. It's the exception. Most things that die on this planet, they vanish, rot, get eaten, get scattered, get erased. Bones, gone. Shells, crushed. Bodies, dissolve before they even had a chance to leave a mark. So when we find a fossil, any fossil, we're not looking at an everyday event. We're looking at a miracle of conditions. Because to become a fossil, you don't just die. You have to die the right way, in the right place, at the right time. And that's rare. First, you need rapid burial, as in immediately. Fall into a muddy river, sink into volcanic ash, get buried in a landslide or sandstorm, that kind of thing. If scavengers get to you first, no fossil. If you're exposed too long, weather eats you alive. If you just die on the surface and nobody covers you, you're history, and not the kind that gets remembered. Next, you need mineral replacement. Over time, the soft tissues decay. Those are gone no matter what. But if you're lucky, the bones, the shells, the hard parts, they absorb minerals from groundwater. Little by little, they turn to stone. Literally. It's not that your bones stay intact. It's that they get rebuilt molecule by molecule in the exact shape they used to be. It's slow. It's delicate. And if anything messes with that process, erosion, pressure, exposure, the fossil never forms. And finally, you need protection. From what? From time. You need to be in a place where you're not going to be crushed, not going to be weathered, not going to be dragged back to the surface too early. Because even if you do become a fossil, if the earth moves the wrong way, if glaciers grind over you, if a river carves through your layer, you're gone. Fossilization is fragile. So here's the brutal math. Out of the billions, literally billions of living things that have existed on this planet, only a tiny, tiny fraction ever left behind a fossil. And even fewer of those are complete. Most are fragments. Half a jaw, a tooth, a piece of shell. That's it. So when people say, why don't we find fossils of a past civilization if they existed? The better question is, why would we? Because even if they had bodies like ours, even if they died in huge numbers, unless they were buried in exactly the right way, in exactly the right place, and nothing touched them for millions of years, there'd be nothing left. So yes, fossils are amazing. They tell us stories we'd never know otherwise. But they're not common. They're not guaranteed. They're lucky. And if a past civilization wanted to leave its mark through bones alone, they'd need more than intelligence. They'd need perfect timing and geological kindness. And Earth? She doesn't hand that out easily.
Not myths or aliens, but an indigenous, intelligent civilization that existed and vanished. Let's clear something up real quick. This isn't about myths. This isn't about ancient gods or spaceships hidden in pyramids. And no, we're not talking aliens. We're talking about Earth's own story, about the possibility of an indigenous, intelligent civilization, one that rose up, made its mark, and vanished. Not a fantasy, not a bedtime story, but a real species, born right here on this planet, just like us. Maybe they walked upright. Maybe they built cities. Maybe they harnessed energy, shaped metal, altered ecosystems. Maybe they even asked the same questions we're asking now. And then, for reasons we may never know, they were gone.
Not moved, not ascended, not abducted. Just gone. Swallowed by time, erased by the same Earth they once called home. So no, this isn't a story about little green men. It's about the terrifying possibility that we are not the first, and maybe not the last, to rise, to build, and to disappear. This is a serious scientific question, not just science fiction. Let's be honest for a second. When you first hear the idea that there might have been another advanced civilization on Earth millions of years ago, it kind of sounds like science fiction, doesn't it? Like something you'd hear in a late-night radio show, or read on the back of a paperback novel at an airport bookstore. It feels like a plot twist in a movie. They were here long before us, and now they're gone. But here's the thing. It's not just a story. It's not just fantasy. This is a serious scientific question. And the more you think about it, the more you realize it's not as crazy as it sounds. Science is full of questions that once seemed ridiculous. At one point, people laughed at the idea that the Earth goes around the sun. They mocked the concept of invisible germs. They thought continents couldn't move until plate tectonics came along. They said the universe was static until it turned out to be expanding. So what makes us so sure we're right about this one? What makes us think we'd recognize another civilization if it came and went long before us? Think about how much we don't know. There are entire species that lived and died on this planet that we'll never discover. Entire periods of geologic time that have left behind only fragments. The fossil record, it's incomplete. The geological record, it's selective. And human history, that's barely a footnote in the story of Earth. So when scientists like Gavin Schmidt and Adam Frank ask, what would an ancient industrial civilization actually leave behind? They're not spinning a sci-fi tale. They're doing what science does best, asking the right questions. Because science isn't about what we already know. It's about what we don't know and what we're willing to explore. And this question, whether a previous advanced species might have lived and vanished long before us, touches every field you can think of. Geology, climate science, astrobiology, paleontology, even philosophy. It's a question that forces us to look deeper, not just into the Earth, but into ourselves. Let's get practical for a second. If a civilization had existed 50, 100, or even 200 million years ago, would we expect to find their cities intact? Of course not. Most of our cities wouldn't last more than a few centuries without maintenance. Nature reclaims. Time erases. Think about how hard it is to find evidence of our own early ancestors, and they lived just a few million years ago. Now imagine trying to find traces of something from 100 million years back. That's not impossible, but it's hard. Really, really hard. And that's what makes the question serious. Because if it's hard for us to find them, it means it might be hard for anyone to find us someday. That's why this isn't just a science fiction idea. It's a kind of mirror. It forces us to think about how fragile our civilization really is, how little time we've had, how little we might leave behind. It makes us realize that being advanced doesn't guarantee permanence. A species could master energy, build technology, alter the ecosystems, and still vanish without a trace. And maybe that's already happened. Maybe more than once. Maybe Earth is like a stage where civilizations rise, perform their acts, and fade. And we're just the current cast. There's another reason why this is a serious question. It's not just about looking backwards, it's about looking forward. Because if another civilization once pushed the planet out of balance, left behind carbon spikes, mass extinctions, or chemical fingerprints, then maybe we're not the first to deal with the consequences of progress. And maybe, just maybe, we could learn something about resilience, about collapse, about humility. Because the more we understand about deep time, about how Earth stores information, about how life leaves traces, the more we understand about ourselves, about what we're doing, and what we might leave behind. So no, this isn't just a wild idea. This is a scientific lens. It's about probabilities, patterns, evidence, and the absence of it. It's about asking, what would survive? What would remain? How would we even know? And those are the kinds of questions that make science powerful. They challenge our assumptions. They stretch our imagination. They pull us out of our little bubble of now. Because science fiction is fun. But science, real science, is where we start asking the deeper questions. And sometimes those questions are stranger than fiction. So next time you hear someone ask, what if we're not the first civilization? Don't laugh. Don't shrug it off. Pause. And consider not just what that might mean for the past, but what that might mean for the future. Because in the end, the most dangerous assumption we can make is that we're the beginning.
The Silurian Hypothesis, 2018. Gavin Schmidt and Adam Frank explored how to detect an industrial civilization if it existed millions of years ago. Let me tell you about one of the most fascinating scientific thought experiments you've probably never heard of. It's called the Silurian Hypothesis. And no, it's not science fiction. It's not a conspiracy theory. It's a serious paper written in 2018 by two actual scientists, Gavin Schmidt, a climatologist at NASA, and Adam Frank, an astrophysicist at the University of Rochester. Yeah, NASA and astrophysics. This isn't the History Channel at 2 a.m. So what exactly were they trying to answer? A deceptively simple question. If an industrial civilization had existed millions of years ago, how would we know? Not a civilization from 10,000 years ago, not ancient Mesopotamia, not the Ice Age. We're talking about the deep past, tens or even hundreds of millions of years ago, before humans, before mammals, before anything that even remotely resembled us. And here's where it gets interesting. They weren't asking, did one exist? They were asking, could we even tell if one had? Because as we've been talking about, Earth doesn't exactly keep good records. It erodes, buries, melts, and recycles. So if a smart species rose up millions of years ago and built a world, could we detect any trace of it today? And if so, what would that trace even look like? That's what Schmidt and Frank set out to explore. Not whether Atlantis was real, not whether dinosaurs had power plants, but how would we, as modern scientists, search for evidence of a civilization so old, so erased by time, that nothing obvious like buildings or tools could possibly remain? It's a bold question, and their approach was surprisingly grounded. They didn't look for giant monuments or fossilized cities. Instead, they focused on what would actually survive. Not artifacts, but impacts. Specifically, the kind of impacts our own civilization is leaving right now. Because we, humans, aren't just building stuff. We're changing the chemistry of the planet. And those chemical changes, they get locked into the geological record,
That's what might last. So Smith and Frank asked, if someone were to study Earth 100 million years from now, what would they find that says something intelligent lived here during the early 21st century? And the answer isn't cell phones or skyscrapers. It's not Wi-Fi routers or Teslas. It's carbon isotopes, plastic polymers, heavy metals, strange layers in the sediment, nuclear signatures, all the stuff we don't think about, but that leaves a mark. Like take carbon, for example. When we burn fossil fuels, we release carbon dioxide into the atmosphere. But not just any carbon dioxide. It has a unique isotopic signature because it comes from ancient organic matter. That signature gets recorded in sediments, in ice cores, in ocean chemistry. So even millions of years later, someone could dig up that layer and say, whoa, something weird happened here. Same goes for nitrogen. Modern agriculture uses synthetic fertilizers that change the nitrogen cycle on a global scale. That shift, it's visible in soil and sediment layers, and it's totally unnatural, meaning it could be a clue of civilization. Then there's plastics. Some of them can degrade, sure, but others, especially when buried deep and protected, could last thousands, maybe millions of years. They might break down into microplastics, but even those, under the right conditions, can persist. A future geologist could find a strange layer in the rock full of plastic dust and think, this wasn't natural. And then you've got metals, not just common ones like iron or copper, but industrial byproducts, cadmium, rare earth elements, synthetic alloys, stuff that doesn't occur in nature in those concentrations. If they show up in the same sediment layer across the globe, it's a red flag. Same with radioactive isotopes. Think nuclear testing. Some isotopes created by nuclear bombs like plutonium-244 have half-lives of millions of years. That stuff stays. If another species dug into the rock and found a sudden blip of radioactive material with no volcano nearby, no meteor crater, no natural explanation, they'd know. Something intelligent had to be behind it. So what Smith and Frank proposed in the Silurian Hypothesis was this. Don't look for bones. Don't look for cities. Look for footprints in the chemistry of the Earth, because that's what survives. That's what we're leaving behind. And if we can recognize those signals in our own time, then maybe we can learn how to spot them in the deep past. Now, they're not saying they found anything. They're saying this is how you would go about looking. It's about developing a method, an approach, a scientific mindset that doesn't just assume we're the first. Because let's be honest, most scientists don't even ask this question. It sounds weird. It challenges everything we think we know. And it forces us to accept that we might not be the top of the evolutionary ladder, but just another rung on a very long climb. So yeah, the Silurian Hypothesis isn't about proving ancient civilizations did exist. It's about figuring out how we'd know if they did. And that's a pretty important question. Because if Earth has had intelligent life before and erased it, then we have to ask ourselves, what will survive of us? And who will be asking the same question about us millions of years from now? They focused on chemical and anomalous signatures, not physical ruins. Here's where it gets really smart. When Gavin Schmidt and Adam Frank set out to explore the Silurian Hypothesis, they didn't go digging for lost cities or ancient skyscrapers buried under the desert. They knew better. Because as we've been talking about, physical structures don't last. They fall apart. They get buried. They get melted, eroded, crushed, recycled. So instead of chasing ruins, they asked a deeper question. What if we searched for chemical fingerprints instead of buildings? Because buildings crumble, but chemistry sticks around. They focused on chemical signatures, things that don't occur naturally or that show sudden global changes. Like what? Like a spike in certain carbon isotopes in the rock record, the kind you get from burning a lot of fossil fuels, or a sudden shift in nitrogen levels, the kind you get from industrial-scale farming, or the presence of synthetic chemicals, plastics, dyes, artificial compounds that don't exist in nature, or heavy metals, cadmium, lead, mercury, in unusual concentrations. If they show up in the same sediment layer across the globe, it's a red flag. Same with radioactive isotopes. Think nuclear testing. Some isotopes created by nuclear bombs like plutonium-244 have half-lives of millions of years. That stuff stays. If another species dug into the rock and found a sudden blip of radioactive material with no volcano nearby, no meteor crater, no natural explanation, they'd know something intelligent had to be behind it. So no, they weren't chasing treasure maps or ancient tech. They were doing something much harder. They were asking how you detect civilization without its stuff, just by reading the planet itself. Like forensic scientists at a crime scene where all the bodies are missing and all that's left is a faint chemical trail on the floor. And honestly, that's kind of brilliant.
Most organisms that die never fossilize, and this is even truer for cultural artifacts. So here's a sobering truth. Most of what dies on this planet leaves no trace. None. Not even a whisper. No bones, no shells, no fossils. Just gone. Decomposed. Eaten. Washed away. Broken down by time and weather and bacteria and bugs. And you know what? That's not unusual. That's not failure. That's normal. Fossilization? That's the rare event. Everything else just fades into the background. So if even living things, creatures with bones, shells, teeth, almost never get preserved, what chance do cultural artifacts have? You know, the things we make, tools, weapons, clothing, furniture, books, artwork, buildings, the stuff that defines a civilization, the stuff that says, we were here, we thought, we created. Yeah, that stuff, it's even more fragile. Let's break it down. Biological remains, like bones, are already built to last longer than most soft materials. But cultural stuff, made of wood, leather, fabric, paper, even early metals, they decay faster than bones. Wood? Rotten in decades. Leather? Gone in years, maybe less. Textiles? Destroyed by moisture, sunlight, microorganisms. Even early metals rust, fall apart, turn to powder in the wrong conditions. So unless those artifacts were accidentally sealed away in a dry cave, under ash, in a bog, or beneath sediment, they don't survive. And even when we do find cultural artifacts, they're almost never intact. We're talking about fragments, broken pottery, a few tools, scattered beads, charred pieces of something that might have been wood. That's the best case scenario. And we're lucky to find those. So now think bigger. If a civilization existed millions of years ago, even just a small, smart species that made things, what would we expect to find? Honestly, maybe nothing. Not because they weren't real, but because the Earth doesn't keep souvenirs. Time is relentless. Soil shifts. Moisture creeps in. Microbes chew through everything. Cultural memory is fragile, and the planet doesn't care how beautiful your temples were, or how many books you wrote, or how advanced your tools were. If they weren't sealed, buried, or fossilized, they're gone. So when people ask,
If someone came before us, why don't we see their stuff? This is the answer. Because stuff doesn't last. Not on this planet. Not over millions of years. And especially not the soft cultural things. The things that actually make us feel human. Fragility of artifacts. Buildings, tools, even metals don't last forever. Most corrode or decompose. Let's be real for a second. We like to think the stuff we build is permanent. We see towering skyscrapers, metal bridges, monuments carved in stone, and we assume they'll be here forever. But they won't. Because the truth is this: artifacts are fragile. Buildings fall. Tools break. Metals corrode. Everything we make, everything has an expiration date. Take a steel beam. It looks tough, right? Solid, strong, but leave it out in the elements long enough, it rusts, flakes, crumbles, vanishes. Even concrete, the foundation of our cities, breaks down. Moisture gets in, freezes, expands, cracks form, and over decades, it starts to fall apart. Stone, it weathers, it erodes. Rain, wind, heat, all of it wears it down. And if nature doesn't get to it first, earthquakes might, or floods, or fire. And now picture a building, any building, your house, a temple, a monument. Leave it abandoned for a century, it's decaying. 2 centuries, it's collapsing. 1,000 years, gone. Unless someone maintains it constantly, it won't survive. And in tools, they're even more fragile. Made of iron, copper, bronze, all of them oxidize. They react with air, water, soil. And what starts as a blade or a chisel ends up as dust. You might find a tiny shard, if you're lucky, but most of it, lost. Even plastics, the things we think of as indestructible, they degrade too. Sunlight, salt water, bacteria. Given enough time, even plastic breaks down. And all of this, we're just talking about hundreds or thousands of years. Now stretch that to 1 million or 100 million. What survives? Almost nothing. Because time doesn't care if it was a monument or a shovel, if it stood tall or fit in your hand. It all breaks. It all fades. It all goes back to the earth. So when people say, if an ancient civilization existed, where's all their stuff? The answer might be simple. It's gone. Not hidden, not stolen, just decayed. It fell apart one molecule at a time until there was nothing left to call a tool or a building or even an artifact. We live in cities made of metal and glass, but deep down we forget. Even the strongest structures crumble under enough time. And in the end, all that remains might not be the things we built, but the changes we made to the world.
Absence of evidence is not evidence of absence. Let's pause for a second and talk about a phrase that's easy to dismiss, but one of the most powerful tools in science and logic. Absence of evidence is not evidence of absence. Now, that might sound like a tongue twister, but it's a concept that changes everything, especially when you're trying to study something as ancient, as mysterious, and as fragile as lost civilizations. Here's what it means. Just because we haven't found proof of something doesn't mean it never existed. Simple, right? But surprisingly easy to forget. We tend to believe what we see, and if we don't see it, we assume it's not real. No ruins must not have been a city. No bones must not have been life. No evidence must be a fantasy. But reality doesn't work that way, especially on Earth. Because like we've said before,
This planet doesn't preserve things nicely. It doesn't freeze history in place. It melts it, crushes it, drowns it, recycles it. We've lost entire forests, entire coastlines, species, ecosystems, and in many cases, we never even knew they existed until we stumbled on a single fossil, or a chemical layer in the rocks, or some anomaly in the data. So when we say there's no evidence of a civilization millions of years ago, that doesn't automatically mean there wasn't one. It just means we haven't found it. Or maybe we haven't even looked in the right way. Maybe we're not asking the right questions. Maybe we're expecting the wrong kinds of signs. Maybe we're assuming their world would look like ours. But what if it didn't? What if they lived differently, built differently, left behind things that don't fossilize, don't endure, or don't look civilized by our standards? Would we even recognize the evidence if it was sitting right in front of us? Let's put it this way. If a group of scientists from the future came back to Earth 100 million years after our civilization had vanished, would they find New York? Probably not. Would they find the Eiffel Tower? Doubtful. Would they find your phone, your house, your car? Nope. But maybe, just maybe, they'd find a weird spike in carbon isotopes, a thin layer of microplastics, unusual concentrations of nitrogen and heavy metals, and they'd have to ask, what happened here? Now, imagine the reverse. If another civilization lived before us, long before us, and all that's left is a strange layer in the rock, would we know what we were looking at? Or would we call it a fluke, a natural variation, a chemical oddity? That's the danger of absence. It can make us confident in something that simply isn't provable, one way or the other. Absence of evidence is not evidence of absence. It's not just a clever phrase. It's a warning, a reminder to stay curious, to stay humble, to never let what we haven't found blind us to what might still be waiting. Because science isn't about having all the answers. It's about asking better questions. And sometimes the best question is, what are we missing? Think about it. We once believed Earth was the center of the universe, that the atom couldn't be split, that no life could exist without sunlight, that continents were fixed in place. We were wrong. Not because we didn't have intelligence, but because we didn't have evidence yet. And when we didn't have evidence, we assumed absence, until someone looked deeper, dug a little further, asked a slightly different question, and suddenly, the whole story changed. So maybe we haven't found proof of an ancient advanced civilization. Maybe we never will. Or maybe we already have, but don't know what we're looking at. Either way, the silence doesn't mean it didn't happen. It just means we need to keep looking, keep asking, keep wondering. Because in a universe as big as this, on a planet that erases its own history, nothing found doesn't mean nothing was ever there.
Silence is a kind of answer. We don't know if we are the first, and may never know, but this doesn't diminish the value of curiosity and humility. There's a kind of silence that echoes louder than any sound. It's not the silence of ignorance, nor the silence of defeat. It's the silence of standing on the edge of the unknown and choosing not to turn away. That's where we are now. We've scanned ancient rocks. We've sifted through layers of sediment. We've traced isotopes and mapped chemical anomalies. And still, no concrete sign that we're not the first. No ancient circuit boards.
No fossilized cities, just quiet. But silence doesn't mean emptiness. It might mean mystery, or warning, or simply patience. You see, the universe doesn't owe us answers. It only offers questions. And what we do with those questions, how we sit with them, how we let them shape us, that is where meaning begins. We may never know if we're the first. Maybe Earth has only given birth to one thinking species. Maybe intelligence is rarer than gold, and we're the first spark in the dark. Or maybe others came before, burned bright, faded, and left behind no voice, only chemical echoes. We can't say for sure, but uncertainty is not failure. It's space. It's openness. It's an invitation. What matters isn't just what we find. What matters is that we keep looking, that we keep wondering, keep asking, keep refusing to believe that the only truths worth chasing are the ones we can hold in our hands. Because maybe the deepest truths, the ones that change us, don't come with proof. They come with perspective. Curiosity is a kind of courage. To look into the abyss of time, to admit how small we are, how temporary, and still choose to explore, is an act of quiet bravery. And humility? Humility is knowing we're not owed survival, that the future isn't promised, and the past isn't fully known. Humility is saying, I may not be the first, and I may not last, but I am here now, and that is enough to ask questions that matter. So, what do we do with this silence? We listen. We slow down. We look at the earth not as conquerors, but as guests. We study not just to dominate, but to understand. We stop treating progress like a sprint and start treating it like a conversation. Across time, across species, across possibilities we haven't yet imagined. Because maybe the real purpose of wondering if we're the first isn't to find someone else. Maybe it's to remember what it means to be worth finding. That if one day, millions of years from now, another species looks back, they'll find traces of us, not just in microplastics or carbon layers, but in wisdom, in restraint, in kindness. In the end, silence is a kind of answer, and what it tells us is simple. You are small. You are temporary. You are part of something vast and ancient. So be humble, be curious, and above all, be thoughtful. Because no matter who came before, and no matter who comes next, you are writing a chapter in Earth's story right now. Make it one worth remembering.
Physical structures, deep, massive earthworks, mines, tunnels, underground facilities might last longer. All right, let's get real for a second. Most people think if an ancient civilization existed, one that came and went millions of years ago, we'd know it. They imagine we'd find temples, pyramids, maybe some futuristic stone tower sticking out of a cliffside. But here's the truth no one wants to talk about. The surface of the Earth is not a safe place for history. Rain eats away at walls, wind smooths stone like sandpaper, plants crack concrete. And earthquakes? They'll turn entire cities to rubble in a heartbeat. In a few thousand years, nature takes back everything. So if you're asking the question, how would we ever find proof of a long-lost civilization? You have to look deeper. Literally. Because there's one place where human hands have left marks that might actually survive. Underground. Think about it. When we dig deep, when we carve tunnels, bore mines, hollow out chambers in bedrock, we're not just building, we're scarring the earth. And scars like that, they don't fade easily. Let's take mines, for example.
Modern strip mines? Gigantic. We're talking hundreds of meters deep, stretching for miles. Machines have reshaped entire mountains, peeled back layers of ancient earth like an onion. We've hollowed out caves to extract iron, copper, lithium, rare earths, leaving behind nothing but voids and spoil heaps. Now, imagine those pits, millions of years later. Even if they collapse, even if they flood, the geology still changed. The strata has been disturbed, and that kind of disturbance, it can survive. Next, tunnels. Not just subway lines or sewers, but deep boreholes, geothermal wells, drilling that cuts straight into the crust. We've sent sensors miles underground. We've buried nuclear waste in salt domes. We've built underground bunkers, so hardened some are designed to survive nuclear war. Who's to say they couldn't survive time? And it's not just what we leave behind, it's how we rearrange the Earth itself. If you ever get your hands on a seismic map of a mining zone, you'll notice the subsurface no longer looks natural. It's been carved, split, shaped. So millions of years from now, some future geologist, human or not, might spot the difference. Might say, this wasn't erosion, this wasn't a lava tube, this was engineered. But let's go darker for a second. Think about underground cities. Yes, we have them. In Turkey, the Derinkuyu complex goes 18 stories below the surface. In Finland, they're building an underground town for 20,000 people. In Nevada, data centers and military facilities dig into the mountains. And during the Cold War, both superpowers buried command centers, missile silos, and bunkers deep beneath granite. Why? Because what's buried is protected. Now, imagine a civilization millions of years ago smart enough to do the same. What if they built not up, but down? What if their legacy wasn't towers in the sky, but cathedrals in the stone? It's a wild thought, but not impossible. Here's where it gets interesting. Deep rock is chemically stable. It's not exposed to acid rain or freezing water. Microbes have a hard time getting in. So if you sealed off a tunnel, left behind a room full of metal beams or ceramics or radioactive waste, there's a real chance. It's still there, waiting, dormant. Let's not forget, even today, we struggle to date ancient underground spaces. A cave in South Africa might hold stone tools from 2 million years ago, and we still argue over the exact age. Why? Because underground is tricky. It's hidden, preserved, but also secretive, which means if there was a deep earth structure from long ago, we might not have found it yet. Or worse, we might have found it and not recognized it. That's the kicker, isn't it? What if we already dug into a strange cavity, odd shape, weird mineral makeup, and just wrote it off as geological anomaly? Because that's the danger of expecting civilization to look like us. Skyscrapers, statues, art. But what if their legacy was a circular borehole in a mountain range? A metallic ore pattern that defies natural alignment? Or a sealed chamber buried so deep no tree root has touched it in 50 million years? That's the lesson. Sometimes the most lasting legacy is the one you can't see, not because it's lost, but because it's below your feet.
Technological footprint in the ocean. Plastic gyres, heavy metal pollution, radioactive isotopes, microplastics can persist. Let's get real for a second. If an alien archaeologist came to Earth 10 million years from now and dug through the layers of rock and sediment, they might never find a single building. Not a skyscraper, not a car, not even a coffee cup. But you know what they would find? Plastic. Not just one piece, not one bottle cap, not a forgotten shopping bag. They'd find an entire layer in the geological record. A strange, thin stratum of tiny synthetic polymers spread across the planet, in the mountains, in riverbeds, and especially in the ocean. because the ocean is where our technological footprint goes to hide, but not vanish, because while oceans break things down, they don't erase everything. They preserve just enough. Think about the plastic gyres, these vast, swirling garbage patches in the middle of the Pacific and Atlantic, some of the size of Texas. They're not just floating junk piles, they're grinding machines, churning plastic waste into tinier and tinier particles, microplastics so small they slip into the cells of plankton. And those particles, they don't decompose, not in years, not in centuries, possibly not in millions of years. We're talking about materials nature has no recipe for. They weren't part of the evolutionary plan. So when they settle into ocean sediment, layer by layer, year by year, they become part of the geological memory of the planet, like fossils, but made in factories. Then there's the heavy metals, lead, cadmium, mercury, rare earth elements from smartphones, batteries, electronics. They don't just disappear. They accumulate. They leach into the water, sink into the seabed, enter the food chain. And once they're embedded in the sediment, they stay. In 50,000 years, someone drilling a core from the ocean floor might see a spike in lead and say, "Something strange happened here." They might not know about gasoline additives or circuit boards, but they'll know we were here. And then there's the radioactive isotopes, stuff like cesium-137, strontium-90, and plutonium-244. You don't get that from nature, not in the concentrations we've left behind. Those came from nuclear testing, from bomb craters, from underwater detonations, from mushroom clouds that reached the upper atmosphere and rained back down over land and sea. And the isotopes? They logged themselves into the earth. Not like scars, more like fingerprints. Tiny radioactive breadcrumbs leading back to one obvious fact. A technological civilization was here. So here's the kicker. If we're leaving behind signs this loud, this lasting, why couldn't someone else have done the same thing? Maybe 1,000,000 years ago, or 100 million years. What if there was a civilization before us, one we never heard of? One whose skyscrapers crumbled, whose monuments washed away, but whose chemistry survived. In layers of plastic we haven't drilled into, in metal residues buried under ocean basins, in odd isotopes we don't fully understand yet. Because the ocean isn't just the planet's garbage dump, it's also its memory card. Silent, hidden, deep. But it remembers. Lost Tech Test. Could the technological activity of a long-vanished civilization still be legible today? The challenge is distinguishing it from natural processes. Let's say you're walking through a rocky canyon. Sun's high, wind's dry, and under your boots, you see a strange black layer running through the stone. It's thin, maybe a few inches. Looks like old volcanic ash. Or maybe not. You bend down, break off a chunk, and suddenly you're not just hiking. You're staring at a question mark embedded in time. Because what if that black layer wasn't a volcano? What if it was a factory? This is the idea behind what scientists now call the Lost Tech Test. It's not a treasure hunt for old gadgets. It's not Indiana Jones with a Geiger counter. It's more subtle than that. It's the question, could we detect the industrial fingerprints of a civilization that disappeared millions of years ago? Not in cities, not in ruins, but in chemistry, in isotopes, in molecular signatures, in things so small they'd never show up in a museum, but so persistent they outlive mountains. Now, here's the hard part. Let's say you find elevated levels of carbon in a layer of rock, or a sudden spike in heavy metals, or unusual ratios of carbon-12 to carbon-13, or even tiny particles of synthetic plastic-like material. That's cool, right? But how do you know it's technology,
And not just nature doing weird stuff, because the Earth is one hell of a magician. Volcanoes release tons of carbon. Methane bursts from melting permafrost. Meteor impacts kick up heavy metals. And the Paleocene-Eocene thermal maximum, it made the world hotter and messier than anything humans have done so far. So here's the challenge. How do you tell the difference between a power plant and a supervolcano? Between a nuclear explosion and a gamma ray burst? Between plastic and some weird organic compound we haven't discovered yet? That's the razor's edge of the lost tech test. It's not about what's there, it's about what shouldn't be there. It's about context, patterns, the impossible coincidence. It's asking, wait a minute, why is this metal showing up here in this layer with no known volcanic source? Or why is this isotope pattern identical to what we see after nuclear fission? Or even, why does this ancient sediment contain long-chain polymers that don't occur naturally anywhere on Earth? The truth is, we're only just beginning to learn how to read the deep history of our planet. We think we're smart. We think we understand geology. But in the grand scheme of time, we're still toddlers poking at the sandbox. And every so often, the sand pokes back. Maybe one day we'll find something we can't explain away with lava or meteors or methane, something that just doesn't belong. And when that happens, we'll have to ask ourselves, was this nature or was this someone like us trying to leave a mark?
Soil holds memory. Charcoal, organic stains, chemical shifts from decaying bodies are fragile and easily erased. You know, we often think of memory as something that lives in our brains, but Earth has a memory too, and sometimes it's buried just beneath our feet. The soil, that everyday stuff we walk on, dig through, grow crops in, it's more than dirt. It's a record, a witness, a fragile diary. And if we listen carefully, it sometimes whispers stories from long, long ago. Here's the thing most people miss. Soil holds memory. Not in photos or words, but in particles, tiny clues about what happened on a patch of land. You see, when a body decays, human or animal, it doesn't just vanish. It leaves behind chemical fingerprints, changes in nitrogen and phosphorus, shifts in pH, even residual fatty acids. There might be charcoal if something burned. There might be dark organic stains, signs of blood, fluids, or decomposition. It's messy. It's ugly. But it's history. In archaeology, some of the most powerful discoveries don't come from golden statues or perfectly preserved bones. They come from soil chemistry. A dark patch under a hut floor, a slight trace of copper near a buried tool, a strange acid imbalance in a spot where nothing grows anymore. These things, they're like echoes of moments we didn't see, but the Earth did. But here's the problem. That memory doesn't last. Not for long. Because the soil is alive. Worms churn it. Roots pierce it. Rain washes it. Microbes break it down molecule by molecule. Give it a few years, and the stain fades. Give it a few centuries, and the chemical trail weakens. Give it a few million years, and it's like nothing ever happened at all. Let's imagine something. A settlement, long before us. People who built homes, cooked food, buried their dead. They didn't use concrete. They didn't leave behind plastic. They didn't carve statues into stone. But the land remembers them. For a little while. The fire pits they built, blackened earth. The garbage they tossed, bits of bones, traces of fat. The bodies they buried, slow-release chemical signatures. For a while, it's all there. But then come the rains, the erosion, the fungi and bacteria, the shifting topsoil. And just like that,
Memory is overwritten. Now, zoom out. Imagine that same process stretched over 1,000,000 years, or 10. Even if a whole civilization lived and died, 1,000 years of farming, feasting, fighting, and fading, the Earth wouldn't keep their photos, wouldn't hold their names. At best, it might hold a shadow, a trace of a trace, a whisper of carbon, a stain where something once was. But even that is pushing it. And that's what makes the search so frustrating and so thrilling. We know the Earth forgets. We know its memory is fragile. But we keep asking anyway. Could something be left? One patch of soil that tells a different story. One tiny stain that doesn't quite add up. Because that's where the real mystery lies. And here's another layer to this. Charcoal. Burn something hot enough and fast enough, and the Earth locks in that carbon. Charcoal can last longer than wood or flesh, sometimes even thousands of years. But still, it's not invincible. Rain leaches it. Wind scatters it. Roots break it up. Bacteria digest it. Even charcoal eventually becomes just carbon again. Unrecognizable. Ordinary. It's a bit humbling, isn't it? We like to think our actions are permanent, that we can leave a mark, that we matter. But the soil disagrees. The Earth says, I'll hold this for a moment, and then I'll move on. So if you're wondering whether a civilization could have risen and fallen long before we ever arrived, without leaving stone monuments or plastic islands, just know this. If they lived close to nature, if they used wood, bone, fiber, if they worked with earth and not against it, then maybe the only memory they left behind was a faint discoloration in the dirt, long since washed away. And that's why the search is so delicate. We're not just looking for buildings. We're looking for whispers in the soil. We're looking for scars on land that's healed. For stories written in charcoal and dust, quickly erased by wind and rain. The Earth remembers, but only for a while. And if we want to find those memories, we'd better ask the right questions before they're gone for good. Non-metallic civilizations. If a civilization used only biodegradable materials, their traces would be extremely hard to find, becoming invisible. Let's pause for a second and ask something simple, but kind of mind-blowing. What if an ancient civilization never used metal? What if everything they built, wore, or touched was made of wood, bamboo, cloth, clay, bone? In other words, what if their entire world was biodegradable? Would we even know they existed? Honestly, probably not. You see, most of what we know about ancient cultures, Egyptians, Romans, Chinese dynasties, Mayans, comes from what survived: stone, bronze, gold, pottery. Not because they were the most important things people used, but because they're the ones that didn't rot away. The truth is, ancient people probably used wood a lot more than marble. But wood decays. Textiles fall apart. Rope unravels. Leather becomes dust. Even writing, if it was done on leaves, bark, or cloth, wouldn't last unless it was stored in a miracle cave. So yeah, if there was a whole society out there singing songs, raising children, planting crops, but they never mined ore or forged steel, they'd be ghosts, invisible to us. Think about it. We assume that advanced means industrial, that technology means metal, gears, engines. But what if there was a different kind of intelligence? What if they figured out how to live in harmony with nature so deeply, so wisely, that their tech left no trash behind? What if they designed for decay? Imagine this. They built cities in the trees. Their homes were woven from leaves, sealed with sap, supported by living trunks. Their tools were carved from coral, bone, polished shell. Their lights were bioluminescent fungus. Their transportation? Trained animals or gliders made from silk and bamboo. Sound far-fetched? Maybe, but maybe not. Plenty of real-world human tribes already live that way, or used to, before contact with industrialized society. And let's be honest, just because something is advanced doesn't mean it has to be destructive. Here's the irony. The more sustainable a civilization is, the less it's likely to be remembered. If they didn't leave scars on the land, no plastic, no metal, no radioactive fingerprint, then the Earth quietly erases their existence, like waves smoothing out footprints in the sand. The paradox is wild. The cleaner you live, the more forgotten you become. And maybe that's the tragedy. Maybe some civilization did reach enlightenment. They figured out how to thrive without drilling or burning or building sky-high towers. They grew, learned, loved, danced, prayed. And then, one day, something happened. Climate, disease, a comet, who knows? They vanished, and the forest took everything back. Now we dig through that same soil, looking for ruins, looking for clues. But there's nothing. Just dirt. Just roots. Just silence. So the next time someone asks, where's the evidence of past civilizations? Maybe the answer isn't, there is none. Maybe the answer is, they were too smart to leave any.
Synthetic materials, microplastics, industrial chemicals, rare metal alloys can persist for hundreds of thousands of years. Let's talk about something most people don't think twice about: plastic. Now, I know, it's boring, it's cheap, it's everywhere, but here's the twist. Plastic is forever. Seriously, that straw you tossed after sipping your iced coffee, that bottle cap on the beach, that grocery bag floating in the breeze, they're not going away. Most people think plastic breaks down, and yeah, it does, but not the way you think. Plastic doesn't disappear, it just gets smaller and smaller, until it becomes what scientists call microplastics, tiny shards, invisible fibers, dust-sized particles. And guess what? They're in everything. They're in the ocean, in the soil, in the rain, in fish, in birds, in honey, even in you. Yeah, every week the average person consumes about a credit card's worth of plastic. No joke. That's what the studies say. And here's the kicker. Once it's in the environment, it doesn't go anywhere. Now, think about this from the point of view of a geologist 10 million years in the future. They dig up some ancient sediment layers, sandstone, clay, basalt. Then they hit something weird, a thin band of rock full of strange fibers and beads, things that don't belong. They run it through a mass spectrometer. Boom. Polyethylene, polypropylene, Teflon. These are not natural molecules. They were made deliberately by something intelligent. And it's not just plastic. Think about industrial chemicals. We're talking about compounds like PCBs, PFAS, dioxins, flame retardants, synthetic dyes, artificial hormones. They're designed to be stable, resistant to heat, cold, acid, bacteria, even sunlight, which means they last. Some of them don't break down for thousands of years. Some never do. These chemicals sink into soil, wash into rivers,
evaporate into air, fall back as rain, get absorbed by trees, plankton, insects, whales. Then those creatures die, decompose, and everything gets buried. And if the conditions are right, that becomes the fossil record. A future paleontologist might find fossilized fish bones right next to traces of artificial estrogen and waterproofing agents. Then we've got metals, but not the kind Earth makes on its own. No, we're talking about alloys, blends created in laboratories, things like titanium aluminum vanadium alloys used in aircraft, neodymium magnets used in electronics, nickel-chromium superalloys used in jet engines and reactors. These combinations don't happen in nature, and many of them don't corrode easily, especially when buried in dry, stable conditions. Even if the structure is destroyed, even if the object melts, the trace metals remain. You can detect them in parts per billion, and if they're there, they don't lie. So now imagine a civilization, not ours, millions of years ago. They don't leave behind pyramids, they don't carve monuments, but they made stuff, advanced stuff. They synthesized materials, they spilled chemicals, they built tech that used rare alloys. They threw it all away. Time passed, the cities vanished, the bones turned to dust, but in the rocks, in the soil, in the glaciers and clay and sediment, the materials stayed, waiting. It's like this. Nature builds things up, then breaks them down. But synthetic materials, they don't follow the rules. They cheat the cycle. And because they don't belong, they stand out, like a shout in the silence of deep time. So when we ask, could an ancient civilization have existed before us, we're not just talking about lost temples or forgotten scripts. We're asking, did someone leave behind a chemical signature, a material that defies nature, a fingerprint in the rocks? Because that's what we're leaving behind, not just plastic bottles, not just chrome and steel. We're embedding unnatural compounds into the crust of the earth forever. And if we can do that, then maybe someone or something did it before. We just haven't recognized the clues yet. Maybe we've already dug up the evidence and threw it away because we didn't think to test it for what it truly is, not just a rock, but a message left by minds we'll never meet. Metals. Most corrode, but some can survive in dry, highly stable environments, caves, deep underground. Let's talk about metal. Not music, not Iron Man, not the stuff in your kitchen drawer. I mean real metal, the earth kind, the ancient kind, the kind that whispers stories through rust. You see, metal is one of the most beautiful lies we've ever told ourselves. We think it's strong, permanent, eternal. But the truth? Most metal dies. It just takes longer than flesh. Iron rusts. Copper turns green. Aluminum pits and flakes. Silver tarnishes. Even gold, the so-called immortal metal, gets scratched, warped, melted, reformed. Time has no patience. It eats everything. Given enough water, air, heat, and time, every man-made thing collapses. But here's where it gets interesting. Not everything falls apart equally. If you want something to survive, I mean truly survive, for millions of years, you can't just leave it lying around. You've got to bury it. And not just anywhere. You need a place where time slows down. Enter the deep underground, the dry caves, the salt mines, the frozen cores, the ancient tombs of geology. These are not just hiding spots, they're time vaults. There are caves on this planet where the air hasn't moved in tens of thousands of years, bone dry, dark, stable, no oxygen, no light, no temperature swings. And inside these natural time capsules, you find things like bronze blades from forgotten wars, coins that still bear the face of kings, tools left behind by miners no one remembers, chains, hinges, clasps, still metallic, still whole. Now, zoom out. Forget human history. Imagine 1,000,000 years, 10 million, 100 million. If something made of metal was tucked away in a deep enough pocket, underground, sealed off, undisturbed, could it still be there? Could it outlive earthquakes, outlast the glaciers, outlast every rise and fall of the oceans? Let me paint you a picture. Somewhere in the desert, beneath layers of limestone, is a cavern that hasn't seen daylight since the age of dinosaurs. Inside, buried under sediment, lies a sliver of shaped titanium. It's not natural. Its edges are straight. Too perfect. Too deliberate. It doesn't belong. And that's the point. Because here's the thing. Nature doesn't forge alloys. It doesn't mix tungsten with nickel. It doesn't plate chromium on steel. It doesn't layer metals with insulators and coatings. We do, or something like us. So when geologists crack open a core sample and find a concentration of rare earth metals where none should exist, it raises a question, or at least it should. But we're not trained to see it. We call it an anomaly. We mark it down, and we move on. Because what else could it be, right? No one was supposed to be here before us. Now imagine a civilization not human millions of years ago, advanced enough to work metal, not advanced enough to escape extinction. They build, they drill, they dig, they vanish, but somewhere in a deep cave, a machine part is buried under a rock slide, forgotten, ignored, preserved. That's the key. Metal can corrode, yes, but corrosion is not destiny. Environment decides everything. In the right conditions, no water, no oxygen, no bacteria, no movement, metal can sleep for ages, still whole, still traceable, still speaking, if we know how to listen. The problem is we rarely look that deep. Most archaeology happens on the surface. Most geology stops at a few kilometers down. But if someone, something, wanted to leave a message for the far future, they'd know better. They'd put it where time walks slow, where pressure seals instead of crushes, where memory has a chance. And maybe they did. Maybe it's still down there, waiting.
Unmistakable signals of current civilization. CO2, synthetic plastics, new minerals, radiation. Let's fast forward a few million years into the future. Picture this. Humanity is long gone. No cities, no Wi-Fi, no airplanes buzzing overhead. Just a quiet Earth, doing what it does best. Forgetting. Rain falls. Rocks shift. Forests grow where parking lots once stretched. The planet reclaims everything. But not everything disappears. Because we left fingerprints, and not the kind that fade. Let's talk about what a future alien archaeologist, or maybe even a future species of intelligent life on Earth, might find when they dig deep enough. And I don't mean statues or skyscrapers. I'm talking about the unmistakable chemical and physical scars that scream, someone was here, and they changed the game. First off, CO2. Carbon dioxide doesn't sound flashy, right? But in the rock layers, it leaves a trace. We've been burning fossil fuels, coal, oil, natural gas, at a massive scale. And the CO2 we've dumped into the atmosphere, it's not just ordinary carbon. It's got a signature. See, the carbon from fossil fuels has a different isotopic ratio, more of the lighter carbon-12 and less of carbon-13. That imbalance,
It's like our industrial breath frozen into the geochemical record. So if you ever see a sudden global shift in the carbon isotope balance in rocks, that's not nature. That's us. Next up, plastics. Ah, yes. Plastic, the miracle and the menace of the modern world. We make it from petroleum. It doesn't rot. It doesn't rest. It just sits there for hundreds, maybe millions of years, if buried deep enough or preserved in dry, airtight places. Future geologists could dig through old landfill layers and find bottles, bags, toys, microbeads, tiny time capsules of our obsession with convenience. And even if the objects themselves don't last, the chemical breakdown products will, mixed into sediments, blended into marine layers, embedded in ancient riverbeds. A message in a bottle, except we're the bottle. Then we've got synthetic chemicals and new minerals. We've invented materials that never existed before us. Think about it. Concrete, aluminum alloys, perfluorocarbons, PCBs, frame retardants, Teflon. Some of these are so chemically stable, they'll last longer than our species ever did. And guess what? Some of these substances might not ever break down in nature. So future scientists will stumble across these strange, unnatural compounds, not made by volcanoes, not formed in meteorites, but crafted by hands that vanished eons ago. And then there's radiation. This one's chilling. From the 1940s onward, we began splitting atoms, testing bombs, launching nuclear reactors, creating isotopes that don't belong in the wild. Plutonium-244, cesium-137, strontium-90. These aren't just rare. Some of them don't occur naturally at all. They're the byproducts of high-tech civilization, and they glow like red flags in the rock record. Even if the buildings all crumble and nature reclaims every city, the radiation signature remains. It's like a scar in the Earth's bones. So imagine thousands or millions of years from now, a future species is doing core drilling. They find a layer in the rocks where carbon dioxide levels spike unnaturally, radioactive isotopes appear out of nowhere, plastics and weird synthetic polymers are locked in the soil. A sudden drop in biodiversity marks a mass extinction. They wouldn't need to find a smartphone. The chemistry would tell them everything. It would say, a civilization once lived here. It burned and built and bloomed, and then it vanished. That's what makes our moment in time so strange, because we talk a lot about leaving a legacy, but in a way, we already have. Not through art, not through books, but through pollution, through the accidental fossils of technology and consumption. That's the paradox. The things we wish would vanish might be the only things that endure. So the question is, if this is the kind of legacy we're leaving, what would you want a future species to think about us? That we were careless? Or curious? That we were destroyers? Or just human? These would be the true fossils of civilization. Not buildings, but chemical echoes. When you think of a fossil, what comes to mind? Maybe a dinosaur bone, a leaf pressed into stone, a trilobite curled up in an ancient seabed. But what if I told you the real fossils of civilization aren't things you can hold? They're not statues or ruins, not ancient cities buried under sand, not some time-worn monument etched with names. No, the true fossils of civilization are chemical echoes. You see, buildings crumble, steel rusts, wood rots, even stone wears down. The wind carves, the rain seeps, the ground shifts, and given enough time, millions of years, everything on the surface is eventually erased. But chemistry, now that's different. Chemistry's stubborn. It sneaks into the cracks, soaks into the soil, swirls through the oceans, and sometimes, just sometimes, it lingers long after everything else is gone. Take carbon, for example. When we burn fossil fuels, we're not just releasing smoke, we're altering the planet's entire atmospheric balance. That change gets recorded, not in paper, not in memory, but in the ratios of isotopes locked inside ancient air pockets or buried sediments. It's like whispering into the rock record. We were here. We changed the air. We left our breath behind. That's a chemical echo. And then there's plastic. You might think of plastic as disposable, cheap, forgettable. But the Earth doesn't forget it. Buried deep, plastic becomes part of the geological layer. Tiny fragments, microplastics, embed themselves in mud and riverbeds, even inside the bodies of animals. They don't biodegrade. They barely break down. They just stay. Long after the culture that created them is gone, the plastic remains, a whisper of mass production, of convenience over consequence, another chemical echo. And don't get me started on synthetic compounds. Our factories and labs have cooked up substances the Earth never knew before. Fluorinated chemicals, artificial dyes, stabilizers, plastics with brand new bonds that nature doesn't know how to digest. These molecules can persist for hundreds of thousands, maybe millions of years, especially in the right environments. They'll outlive the languages we speak, the borders we draw, and maybe even the species we are. Their silence, louder than any monument. And then there's radiation. This one's chilling. The atomic age carved a scar into the planet. Not a physical wound, but an invisible one. A radioactive signature. Some isotopes we've created don't occur naturally at all. They only show up after nuclear reactions. So if some geologist a million years from now drills into the Earth and suddenly finds a thin band of plutonium-244 or cesium-137, they'll know. Something powerful, something intelligent, once walked this Earth. All these signals, carbon shifts, plastics, synthetic molecules, radioactive isotopes. They don't stand tall like a temple or a statue. They don't sing like a poem or a song. But they speak, quietly, relentlessly. They echo through time. And that echo, for all its subtlety, might be the only trace left of us when the dust finally settles. Here's where twist. Civilizations rise with noise, fire, and ambition, but they leave behind whispers. Not of their dreams, not of their music, not of their art, but of their chemistry. And that's humbling, isn't it? We imagine greatness in skyscrapers, immortality in monuments, legacy in what we build. But time isn't kind to concrete. It doesn't care for architecture. It has no respect for blueprints. It listens only to atoms, and it remembers in molecules. So maybe, just maybe, the most honest legacy we leave won't be in history books or digital clouds or buried cities. It'll be in the dust, in the layers of soil, in the quiet chemistry of the Earth. That's where the truth of our civilization will lie. Not as statues to be admired, but as signatures to be decoded. Chemical echoes, the final fossils, unintentional, unseen, undeniable.
Bias in scientific interpretation. We tend to see what we expect. The idea of pre-human civilization is hard to accept. Let me ask you something. When you look at a cloud shaped like a face, do you see a message? Or do you shrug and say, just a coincidence? Now imagine you're a scientist, trained your whole life to find patterns. But not any patterns, the expected ones. The ones that fit the story you already believe. That's where bias sneaks in, not as a villain, but as a shadow wearing your own coat. Scientific bias isn't some grand conspiracy. It's a human thing. We crave certainty, we crave order, and we build entire frameworks of thought, whole mental cities, on the foundation of what we expect to be true. So when an idea like pre-human civilization comes knocking, our reflex is almost instant. Nah, that's not science, that's fantasy. But wait a second. Let's be honest. Is it that the evidence isn't there, or that our minds are trained to look past it? Consider this. If you've spent decades studying geology, you've been taught that Earth is slow, steady, predictable. Civilizations don't come and go over millions of years. They show up recently, and they look like us. So if a layer of strange isotope shows up, or a shift in sediment that doesn't quite make sense, your brain instantly reaches for the natural explanation. Volcano, probably. Could be an asteroid. Might be climate variation. Rarely does it whisper, what if this was made? Because that's uncomfortable. It opens the door to doubt. And doubt is risky in a world that rewards certainty. Here's another wrinkle. The idea of a non-human civilization, that's existentially unsettling. It tells us we're not unique, not the first, not the pinnacle of intelligence. It says we're part of a cycle, not the center. And that hurts our ego. Deep down, many of us, scientists included, carry a subconscious belief. Humans are special. This planet waited for us. So anything that challenges that, it gets labeled myth, pseudoscience, or science fiction real quick. Not because it's wrong, but because it's too weird to fit the story we've told ourselves. Let me give you a metaphor. Imagine you're handed a puzzle box, but someone already told you it's a bird. You spend hours trying to find wings, feathers, a beak. But what if it's not a bird? What if it's a fish? You might never see it. Not because the fish is invisible, but because you're only searching for birds. That's what scientific bias does. It narrows your view without you even realizing it. There's a famous phrase in science, you can't prove a negative. And it's true. Just because we haven't found ruins, or bones, or inscriptions, doesn't mean an ancient civilization never existed. Absence of evidence is not evidence of absence. But if you're biased to think it never happened, then you'll interpret silence as confirmation. It's like tuning a radio to one frequency and claiming nothing else exists. Maybe you're just on the wrong channel. Now, this doesn't mean we should believe every wild theory. Of course not. Skepticism is essential. Discipline matters. Science has to filter nonsense from insight. But we also need courage. The courage to say, what if I'm wrong? What if our model of history is missing a chapter? What if I'm not seeing because I wasn't taught how to look? And here's the irony. Every major scientific revolution started with someone seeing what wasn't expected. The Earth wasn't flat. The sun didn't revolve around us. Time isn't absolute. Dinosaurs had feathers, and yes, continents drift. Each of those ideas sounded crazy, until they didn't. So why not this? Why not entertain the possibility that someone came before us? Why not at least look? Let me end with this. If there was an ancient civilization, deep in time, lost to erosion, buried under oceans, they might have left behind only traces, not statues, not tools, but chemical whispers. A spike in CO2, a drop in biodiversity, anomalous metals, a sharp line in stone. And if we're too blinded by bias, we'll walk right past it. We won't even know what we just missed.
Studying our own footprint helps visualize what kind of evidence might persist over long periods. So here's a weird but powerful thought. We are the experiment. If we want to know whether an ancient, advanced civilization could have existed millions of years ago, we don't have to guess. We just have to look at ourselves. Look at what we're leaving behind. Because we are, right now, in real time, writing our story into the layers of the earth. Not with books, not with photographs, but with chemistry, with pollution, with scars in the atmosphere, the soil, the sea. And that's the key insight. By studying our own global footprint, we can begin to imagine what kind of clues might survive if anyone like us came long before. Let's say you're a scientist 1,000,000 years in the future. You dig into a cliffside, a riverbank, or an ocean trench. What would you find? You might not find smartphones or laptops, but you'd probably find layers of rock containing plastics that never fully broke down, a spike in carbon from fossil fuels, unnatural nitrogen from industrial farming, strange metals not found in nature, and maybe, just maybe, traces of radiation from nuclear tests. These are our chemical fossils, and they're far more durable than buildings or bones. And here's the twist. If this is what our civilization looks like geologically, then what would someone else's look like? If there really was an intelligent species 100 million years ago, before humans, before mammals even, what might their footprint have looked like? Did they burn fuel, mine rare metals, alter the soil to farm, create synthetic materials? If they did, and if their chemistry was even remotely like ours, then maybe, just maybe, they left behind some kind of echo in the earth, a blip, an anomaly, a chemical scar in stone that no volcano or asteroid could explain. So studying our own mark on the world doesn't just tell us about us. It becomes a mirror into the deep past. It gives us a blueprint, a detective kit for recognizing civilization even when everything physical has vanished. And here's the part that really messes with your head. If we can recognize the traces we're leaving, and if those traces are the only things that might survive the next 1,000,000 years, then maybe, if we know how to look, we might still catch a glimpse of someone who came before. Not with temples, not with machines, but with tiny, stubborn molecules in the dirt. That's why this is more than a science fiction idea. It's a real, testable hypothesis. It's a call to look again at the Earth's deep history and ask, are there clues we've missed? Because if we are writing our story in plastic, concrete, nitrogen, and isotopes, then so might they have. The past may not be as empty as it seems. The geological record is full of gaps. Many periods are completely erased by erosion and tectonic activity. Let's talk about memory. Not human memory, Earth's memory. Because just like people forget, so does the planet. We tend to imagine the Earth as this ancient historian, a stone-faced keeper of everything that ever happened. But here's the uncomfortable truth. The Earth forgets all the time. You see, the geological record, the layers of rock and sediment that tell the planet's story, is not a perfect book. It's not even a full one. It's more like a journal that got rained on, burned, buried, torn apart, rewritten, and then dropped in the ocean for 4.5 billion years. There are huge gaps, entire chapters missing. Some layers were never written because no sediment formed. Others were erased, scrubbed clean by wind, water, earthquakes, or fire. And many were simply buried too deep to read. Think about this. We can read certain parts of the Earth's crust like a timeline. This layer is from 10 million years ago, that one from 300 million years. But then there's just nothing. A whole era gone. No fossils, no rocks, no chemical record. It's not that nothing happened.
It's that everything that did happen was later erased. And the number one culprit? Erosion and tectonic activity. Let's break that down. Erosion. Water flows, rain falls, winds howl, glaciers scrape, storms crash. And over thousands, millions of years, they carve down mountains, they flatten valleys, they strip away entire layers of the past like peeling off wallpaper, except this wallpaper is made of rock. Whatever was once there, bones, ruins, fossils, ash, sediment, vanishes. Erased, shredded, recycled by the planet itself. And that's the brutal part of this whole investigation. We're not just looking for a needle in a haystack. We're looking for a needle in a haystack that caught fire, got buried, and then was swallowed by an earthquake. So when scientists say the geological record has gaps, they don't mean a few missing pages. They mean entire volumes vanished without a trace. But yet we keep looking. Because sometimes, just sometimes, something does survive. A fossil, a mineral anomaly, a sudden shift in isotopes. And when that happens, we get a glimpse, not of certainty, but of possibility. That's the promise of the Silurian hypothesis, not to prove there was another civilization, but to ask, if there had been one before us, would we even know? And the answer, disturbingly, might be no. Because Earth doesn't save everything. In fact, it erases most of it.
Geochemical anomalies, changes in stable isotope ratios, carbon, oxygen, nitrogen, could suggest industrial processes. Let's imagine something weird shows up in a rock sample. You're drilling down into ancient layers of Earth, layers that haven't seen sunlight for millions of years. You run your tests, you expect the usual results, but then, boom. The carbon levels are off. Not wrong, just different. The ratio between carbon-12 and carbon-13 doesn't match what you'd expect from natural processes. Same thing with oxygen or nitrogen. That, my friend, is a geochemical anomaly. Now, before your eyes glaze over, because yeah, isotope ratios sounds like science class, let me break it down. Atoms come in flavors. You've got your typical carbon, carbon-12. Then you've got its chunkier cousin, carbon-13. Same element, just a little heavier. And nature usually leaves behind a consistent pattern in how these isotopes show up. Burn a forest, bury a volcano, melt an ice cap. Each process leaves a predictable fingerprint. But when humans get involved, when we dig, burn, refine, or nuke something, we break that pattern. Suddenly, the ratio of carbon-12 to carbon-13 isn't what it's supposed to be. This is the key. Industry leaves invisible fingerprints. Even if you burn every blueprint, smash every machine, erase every database, your factories, your cars, your power plants, they whisper to the rocks. They change the chemistry of the air, of the soil, of the oceans. And over time, those changes settle into stone. So let's say 100 million years from now, a geologist digs through today's strata and sees this weird carbon spike. That scientist might not find your city. They might not know your name, but they'll know something happened, something unnatural, something industrial. Now here's where it gets truly wild. Let's flip the telescope backwards. What if we find a carbon anomaly, but from 100 million years ago? Not from now, not from humans, from long before mammals even showed up. Wouldn't that raise some eyebrows? It has, actually. Geologists have already noticed strange isotope shifts in ancient rock, changes that don't quite add up. Sure, there are natural explanations.
Massive volcanic events, methane bursts, asteroid impacts. But what if one of those weird spikes wasn't nature at all? What if it was someone else? You see, the Silurian hypothesis isn't trying to prove there was an ancient industrial civilization. It's asking, if there was one, what would we look for? And one answer? Geochemical anomalies, stable isotope ratios, unexpected ratios, unnatural patterns in the rock. Think of it like ancient graffiti, except it's not on a cave wall. It's coded into atoms, left not by intention, but by side effect. Farming could shift nitrogen isotopes. Coal burning could change carbon. Manufacturing could leave behind strange metals and compounds. And once it's in the system, it's stuck there, because the Earth doesn't scrub its chemical history as easily as it does cities or bones. Now, let's not get carried away. Just because something's weird doesn't mean it's alien or ancient industry. Nature's messy. Volcanoes can belch out bizarre isotope patterns. Ocean currents can trap and release gases in strange ways. But still, if the same odd signals show up in multiple places, across continents, across layers, we should pay attention. Because even if we can't dig up a lost city, the rocks might be whispering, "You're not the first." Let's talk about plastic. Yeah, plastic. The stuff we wrap sandwiches in, the bags we forget at the grocery store, the bottles we toss, recycle, or, let's be honest, sometimes just leave on the beach. Seems like nothing, right? Cheap, throwaway, disposable. But here's the kicker. Nature doesn't know what to do with it. Plastic isn't part of the original Earth recipe. It's not wood, not stone, not even metal. It's pure invention, engineered by humans in labs, created from fossil fuels, structured at the molecular level to last. And boy, does it last. We used to think plastic took a few hundred years to break down. Now we're realizing that even after it breaks down, it doesn't disappear. It just becomes smaller. First a cup, then a shard, then a crumb, then a speck so tiny you can't see it. Microplastic. But it's still there. Still plastic. Still foreign to nature. Now imagine this, 1,000,000 years from now, long after cities have crumbled, languages forgotten, and continents shifted, a geologist cracks open a rock layer from our time and finds specks, tiny, indestructible polymers, stuff that was once a soda bottle, or a phone case, or a Barbie doll. Still there, embedded in stone, unmistakably synthetic. And that's the thing about plastic. It's more durable than almost anything else we've ever made. Under the right conditions, buried in sediment, shielded from sunlight and oxygen, it doesn't rot, it doesn't rust, it just sits, waiting, like breadcrumbs for future scientists. And it's not just plastic. There are chemicals too. Non-natural compounds we created that never existed before humans. Pesticides, industrial lubricants, fire retardants, coolants. Some of them are so stable, so persistent, they've earned a scary nickname. As forever chemicals. They don't go away. They don't fade. They just build up, molecule by molecule, inside water, inside animals, inside us, and eventually, inside rock. Here's where things get interesting. Let's say one day Earth starts over. Civilization collapses. Forests take over. Skyscrapers fall. And then millions of years later, some future species starts digging. They find a layer in the Earth, dark, strange, filled with weird compounds that don't fit any natural explanation. Maybe they can't read our history. Maybe they never find a fossil of us, but they'll find our plastic, our chemicals, our shadow. This is why the Silurian hypothesis matters, because if we're leaving behind such resilient, unmistakable signatures, then maybe, just maybe, someone else once did too. And maybe we've missed it, or misunderstood it, or written it off as a strange blip in the data. And think about it. If a past civilization was smart enough to build, to create, to change the world like we have, they probably also made things that lasted. Not skyscrapers, not smartphones, but traces, chemical signatures, synthetic materials, microscopic fingerprints in the layers of time. And someday, long after we're gone, the Earth might whisper our name in plastic.
Lost voices. Let's play a dangerous game. What if we're not the first? Not the first to build, not the first to burn, not the first to think we're invincible. What if others came before? Not aliens, not myths, not beings from another dimension, but people from Earth, born here, lived here, loved here, and then disappeared. Crazy? Maybe. But let's be honest. Our entire history, our whole civilization, fits into a cosmic blink. We've been building cities for 6,000 years, farming for 10,000, burning fossil fuels for about 150. The Earth is 4.5 billion years old. Do the math. There's so much time, so much we'll never know. Now, think about this. What if a civilization rose, say, 100 million years ago, back when dinosaurs still roamed? Maybe they weren't like us. Maybe they didn't make steel or write code, but maybe they were smart, curious, organized. Maybe they changed their world. Maybe they left clues. Clues we mistake for something else. A weird chemical anomaly, a spike in carbon, a strange layer in the rocks. We look at it and say, huh, volcano. But maybe, just maybe, it wasn't a volcano. Maybe it was a power plant. Here's the real kicker. We don't look for what we don't expect. Our science is smart, but it's still human. We carry bias. We chase what we can explain. We laugh off the rest. If you told a scientist in 1850 that plastic would someday be part of the fossil record, they'd call you insane. And yet, here we are. So, what if the reason we haven't found another civilization is because we don't recognize it? What if the ruins we expect, pyramids, tools, art, were never left behind? What if the only thing that remains is chemistry? A signal, a distortion, a blip in the rocks that says, someone was here. They burned, they consumed, and they left. Not on purpose, not dramatically, just inevitably. And let's not forget, we're bad at keeping things. The Earth recycles everything. Mountains crumble, seas rise, continents collide. You think your city's gonna last forever? Try telling that to Pompeii, or Atlantis if that was even real. And underwater? Forget it. If a civilization lived on an island that's now under the ocean, we'll probably never know.
Underwater archaeology is brutal. Most of the continental shelves we walk past on vacation used to be dry land. Tens of thousands of years ago, entire coastlines were somewhere else. So yeah, if a people live there, their voices are gone, drowned, buried, crushed. But here's where it gets really haunting. Let's say one day we do find something. Not a statue, not a scroll, but something small. A signal. A pattern in the rocks. An unnatural layer. And suddenly, everything changes. Our sense of history, our sense of destiny, our place in the universe. Because now we know we weren't first. We won't be last. And survival isn't guaranteed. It's a humbling thought. One that makes your daily commute feel a little less important. One that makes you look at the earth not just as a home, but as a witness. It's been here for everything, and it forgets almost everything. So if someone did live before us, they're not gone because they were dumb. They're gone because they were mortal, just like us. And maybe, just maybe, that's the real reason to care. Not because we'll find ruins, but because we might be the ruin someday. And how we're remembered depends on the mess we leave behind.
Fingerprints in stone. So if we're not digging for lost cities or alien tech, what exactly are we looking for? The answer? Chemistry. See, civilizations, ours included, leave behind chemical footprints. Not because we try to, but because we can't help it. Every factory, every car engine, every power plant, we change the chemistry of Earth. We pump CO2 into the sky. We dump nitrogen into the soil. We scatter plastics across oceans like confetti. And that's the weird part. Those changes, they're easier to find in 1,000,000 years than a skyscraper. Let me break it down. CO2 with strange isotopic ratios. That's science speak for this carbon came from burning fossil fuels. Fly ash and coal particles baked into ancient rock layers. Radioactive leftovers from nuclear tests. Plutonium-244 doesn't just appear in nature, folks. These are not normal. These are not natural. These are human. So now we flip the question again. What if someone, or something, left signs just like these long before us? Not buildings, but anomalies, chemical hiccups that don't quite make sense. Sudden drops in biodiversity, strange shifts in carbon, mysterious layers of ash in the middle of an otherwise quiet period. What caused them? Volcanoes? Maybe. Meteor strikes? Could be. Industrial activity? Now, that's a thought. And no, this isn't fantasy. It's science. Real science. In 2018, 2 scientists, Gavin Schmidt and Adam Frank, published a paper asking, could we detect an industrial civilization in the geological record? They called it the Silurian Hypothesis. Yeah, it sounds like science fiction, but it's grounded in facts. They weren't saying a past civilization definitely existed. They were asking if it did, what would be left? The answer? Not much, but maybe just enough. Maybe a spike in carbon isotopes here, a layer of weird plastics there, an unexplained warming event sandwiched between ice ages. Not proof, but clues. Breadcrumbs scattered across deep time. And here's the twist. We're already seeing those clues, but we blame them on natural causes because, well, no one expects civilization before civilization.
If an ancient civilization once existed, why haven't we found them? Have you ever stopped to wonder, if there really was a highly intelligent civilization before us, why haven't we found anything? No rusted tools, no buried cities, no weird satellites floating in space. Nothing. Shouldn't we have found something by now? But hold on. Take a step back. Let's look at where we are. Earth. Earth isn't a museum. It's a memory-erasing machine. Wood rots, metal rusts, bones dissolve. Nothing on this planet was made to last forever, at least not on the surface. You build a house out of bricks, leave it alone for a few centuries, and it becomes a ruin. Give it a few thousand years, and it disappears beneath vines, soil, and time. A few million years? Forget it. It's gone like it never existed. Time doesn't just pass. It works. It buries. It melts. It crushes. It shifts. And most of all, it erases. Earth is the ultimate recycler. It doesn't preserve, it transforms. Here's something wild to think about. Every couple 100 million years, the surface of the Earth completely changes. Continents drift, oceans rise and fall, mountains grow and crumble. What you're standing on today might have been a seafloor 300 million years ago. Our civilization has never faced the test of time. We've only been leaving marks on this planet for, maybe 300 years? Since the Industrial Age. That's nothing. That's a breath. That's not even a blink in geological terms. Skyscrapers, power plants, space stations, they all feel permanent, but none of them have been around long enough to prove they'll survive deep time. So let's ask the big question. If we disappeared tomorrow, what would be left of us in 1 million years? In 10 million? In 100 million? Maybe we're looking in the wrong place, or worse, for the wrong thing. We imagine finding ancient pyramids buried in jungles, or lost spacecraft under miles of rock. But what if the only thing left is a weird chemical signature in the soil? What if it's just an unusual carbon ratio trapped in rock layers? Would we recognize that as proof of intelligence? Or would we chalk it up to some unknown natural event, like we've done so many times before? The problem isn't that they left nothing behind. The problem is, we might not know how to read what they left. It's like trying to decipher a book written in a language we've never seen, that's been buried in mud for millions of years. So here's the real challenge. Do we have the curiosity and the humility to notice the strange and ask if it might be more than just natural? Because maybe the echoes of a forgotten civilization aren't made of stone. They're chemical, they're subtle, and they're buried deep in time.
The ghosts of forgotten cities. Imagine a city not made of glass and steel, but of clay, bamboo, and dreams. No cars, no wires, no digital noise, just quiet innovation. An indigenous civilization, not from outer space, not mythic gods, just people, like us, with minds that questioned, hands that built, and hearts that hoped. Now imagine that city swallowed by time, not destroyed, just forgotten. What if they lived near the coast? A rising sea takes what it wants. One century you have farmland, next century it's ocean floor. Sand moves, tides shift, and whatever was there, gone without a scream. What if they lived on islands? One earthquake, one volcanic belch, and entire cultures slide beneath the waves. We don't even know the names of the languages we lost that way. And what if their tools weren't made to last? If they shaped the world with bamboo instead of bronze, wove cloth instead of carving stone, built homes to blend with nature instead of conquer it, then those cities wouldn't become ruins. They'd become compost, reclaimed, recycled,
absorbed into the forest, into the soil, into memory, and eventually into silence. That's the puzzle. We're trained to look for monuments, stone heads on islands, pyramids in jungles, but intelligence doesn't always build up. Sometimes it blends in, and sometimes it fades out on purpose. Think about our own cities, skyscrapers, highways, airports. What happens if we're gone for 1,000 years? Steel rusts, glass breaks, concrete crumbles. Now fast forward 1,000,000 years. The forests take over, the oceans rise, the earth forgets. Maybe there's a bump in a hill where a stadium once stood. Maybe there's a weird layer in the soil where plastics used to be. But will anyone recognize us for what we were? That's the irony. We assume that progress leaves behind a trail. But what if the most advanced civilizations leave behind nothing? No smoke, no trash, no scars. Just balance. Just silence. You might say, well, if there was a city, someone would have found it. But would they? Remember, over 70% of Earth's surface is underwater. And underwater archaeology, it's not Indiana Jones. It's expensive, it's slow, it's blind. We've mapped Mars better than we've mapped our own seafloor. Whole shelves of ancient coastline could be hiding the answers we seek. And even on land, tectonic plates shift, rivers carve, mountains rise. The Earth isn't a museum. It's a demolition crew. It doesn't curate, it resets. So what are we left with? Traces in chemistry, hints and isotope ratios, anomalies in the carbon record. That's the fingerprint we might leave behind. And maybe, just maybe, that's the same kind of echo we should be listening for. Because if we only look for statues, we'll miss the civilizations that never built any. If we only dig for gold, we'll miss the wisdom written in carbon. And if we only search where it's easy, we'll never find what's been buried on purpose. The truth is haunting. We might not be the first, and we might not be remembered, unless we pay attention to the faintest whispers, not of what was said, but of what was done.
A civilization measured in shadows. Let's say for a second, you're a time traveler. Not one with a flashy DeLorean, but one armed with a shovel and a microscope. Your mission? Find proof. Any proof that someone came before us. Not a rumor, not a myth, but cold geological evidence. You don't get ancient scrolls, you don't get murals or monuments. All you get is sediment, stone, chemistry, and silence. So what are you really looking for? Not the obvious. No bones in a museum. No crumbling temples in the jungle. You're looking for shadows. Footprints, not of feet, but of fossil fuels. Signals, not from satellites, but from isotopes. It's not the stuff that was built. It's the scars left behind by building. That's how civilizations speak across eons. Not in words, but in changes. Think about our own world. We've covered continents in cities, filled the oceans with plastic, jacked up CO2 levels like a fever chart gone wrong, created new minerals, ones that have never existed naturally, even detonated bombs that left radioactive fingerprints in the soil. If someone found that 1,000,000 years from now, they'd say, something intelligent lived here, and it got busy. But here's the twist. Even our clearest signals fade.
The ocean stirs and erases. Wind and rain smooth everything over. Tectonic plates recycle the crust like a cosmic paper shredder. What survives? Maybe plastic molecules, if they're lucky. Maybe some weird spike in nitrogen. A blip in the carbon ratios. A ghost in the chemistry. Nothing you can put on display, but something you can measure. Something that says, someone did something unnatural here. And that's the frame of the Silurian Hypothesis. If we want to detect a lost civilization, not just from 1,000 years ago, but from 100 million years ago, we have to stop looking for walls and wheels. We have to start looking for shadows, for anomalies, for the weird, the out of place. Let me give you a picture. You're drilling into ancient shale deposits. You hit a layer of rock, normal, then boom. Sudden carbon spike. Sharp drop in biodiversity. Trace of synthetic compounds. A layer of ash. No meteor, no volcano, just a disruption. Something acted on the planet, and then it stopped. Like a breath held, then gone. Now here's the catch. Nature also makes weird stuff. Volcanoes belch out CO2. Methane clathrates melt and cook ecosystems. The Paleocene-Eocene thermal maximum looked a lot like what we're doing now, minus the Wi-Fi and SUVs. So how do you tell the difference? That's the game. That's the challenge. Not just did something happen, but was that something intelligent? It's kind of poetic, isn't it? The smarter a civilization is, the less it might leave behind. If they were sustainable, they might be invisible. No mass extinctions, no plastic plague, no radioactive trail, just harmony, just balance, just gone. Would we even know they were here? Would we even know how to look? This isn't just about history, it's about perspective, because maybe the measure of a civilization isn't in what it builds, but in how long its echo lasts. A skyscraper is impressive, but a carbon fingerprint? That sticks. That speaks. That's the whisper in the soil saying, we were here. You might be next. And that brings us to the uncomfortable truth. We might already be leaving our echo. Not a proud one. Not a golden record, but a scar. Our climate, our chemistry, our chaos. Maybe one day someone will read it, and maybe they'll ask the same question we're asking now. Were we the first? Or did we just forget to look deeper?
The silence between the layers. Let's say you're digging through rock, layer by layer. Each one is like a chapter in Earth's diary. Some layers are full of life. Fossils, shells, leaves turned to stone. Others, just silence. Nothing. Blank. But here's the thing. Silence doesn't mean nothing happened. It might mean something happened so fast or so strangely that nothing was left behind. Or worse, it might mean everything was erased. Think about this. Out of every living thing that's ever walked, swam, or flown across this planet, almost none of them left a fossil. Fossils are rare. They only happen when the conditions are just right. Buried fast, protected, slowly turned to stone. And when it comes to buildings, machines, or cities, the odds are even worse. Our planet is not built to keep secrets. Tectonic plates grind across each other like giant erasers. Oceans rise up and drag down entire coastlines.
Wind and rain carve everything down like sandpaper. You want to hide something from time? You better bury it deep. And even then, it's no guarantee. So, let's flip the idea. What if a civilization did rise up, but it lived near the ocean? After all, most of our cities today are coastal. It makes sense. Trade, water, food. But that's also where destruction happens fastest. Over millions of years, coastlines move, islands sink, ocean floors get shoved under continents and melted. That's right, melted. Gone, erased. So maybe the evidence isn't lost. Maybe it was never allowed to stay in the first place. Here's another twist. What if they were smart, but didn't leave a mess? We assume that technology means metal and concrete and trash. But what if they used biodegradable materials? What if their tools decomposed like bamboo and leaves? Think about us. We've left mountains of plastic. They'll probably outlast us all. But if someone, or something, had learned to build in harmony with nature, using only what returns to the earth, we might never even know they were here. No ruins, no metal, no wires, just soil. Now let's go deeper. Some scientists, real scientists, not science fiction writers, have actually asked, if there was an industrial civilization millions of years ago, how could we detect it today? Not by looking for cities or spaceships, but by looking at the chemistry of rocks, at the isotopes in ancient layers, at strange spikes in carbon or sudden changes in nitrogen. Because that's what we're leaving behind now. Not monuments, not memories, but fingerprints, invisible ones.
The deep time perspective. Why our timeline might be too small to see the whole picture. Let's zoom out. Way out. Not just centuries, not just millennia. Let's talk millions of years. That's deep time. The kind of time our brains aren't built to understand. We live in snapshots, birthdays, decades, family trees, historical events. To us, 1,000 years feels like an eternity, but to Earth, it's a nap. Dinosaurs ruled for 165 million years. Humans have existed for about 300,000. Modern civilization? Maybe 6,000 years, tops. That's 0.003% of Earth's lifespan. Think of Earth as a 24-hour clock. If the planet was born at midnight, our entire modern history shows up in the last few seconds before midnight ends. The Industrial Revolution? Less than a blink. TikTok? A nanosecond. So what are the odds that our moment in time is the only one that's ever mattered? What are the chances that intelligent life only happened now, on a planet that's 4.5 billion years old? Really? Here's the problem. We tend to look back in time like we look down a hallway. Clear, linear, easy to trace. But Earth's past isn't a hallway. It's a maze. It folds. It buries itself. It rewrites. Every 100 million years, the surface of the planet reshuffles like a deck of cards. Mountains rise, oceans fall, continents drift, ice ages erase. Even if a civilization had built wonders, nature had hundreds of millions of years to eat them. Turn stone into dust, steel into rust, memory into silence. And most of the time, the ground we dig into doesn't go deep enough. We only explore layers where fossils still whisper. Go too deep, and you hit heat, pressure, and time. History melts. So maybe we haven't found evidence of ancient intelligence because we're looking too narrowly, too recently, too shallowly. We're trying to read a novel with only 3 pages left in the book, and yet we act like we know the whole story. That's not science. That's ego. Here's the twist. Geology doesn't care about our pride. It records what it can, then it wipes the slate. That's what deep time does. It's the ultimate editor. It doesn't care what's important. It just keeps moving. Think about how long it takes for just one fossil to form. Now think how rare it is for a piece of technology to survive more than a few centuries. Now multiply that by millions of years, with earthquakes, volcanoes, erosion, subduction zones, ocean currents, and we still wonder why we haven't found anything. Maybe the absence of evidence isn't because nothing existed, it's because time is a destroyer. Still not convinced? Let me ask you this. If our civilization vanished tomorrow, how long would it take for everything we built to vanish too? Skyscrapers crumble, glass shatters, steel corrodes, satellites fall, cities drown. Even our most enduring creations, like monuments, tunnels, or landfills, wouldn't last more than a few million years at best. And in a billion years, nothing. Unless it's chemical, unless it's subtle, unless it's in the right place. So maybe the reason we haven't found signs of ancient intelligence isn't because it never existed, but because we're looking with short-term eyes on a long-term planet. The next time you stare at a rock, or walk a beach, or look up at a mountain, ask yourself, what stories might be buried beneath? What lives came and went long before us, and will never be seen again? Deep time is humbling. It makes us small. It makes us silent. And maybe that's the point. Maybe we're not supposed to have all the answers. Maybe we're just here to ask better questions.
Civilization without steel. The possibility of bio-based ephemeral technology. Let's ask a question that flips everything on its head. What if the most advanced civilizations never used metal? What if they never mined copper or forged steel? What if their tools weren't carved from stone, but grown from cells? Sounds like science fiction? Maybe. But think of this. We are already moving toward biodegradable electronics, lab-grown materials, organic circuitry. And we've only been industrial for a couple hundred years. Now imagine a species with 1 million years of technological head start. Would they still be digging into the earth, smelting ore, dumping waste? Or would they have mastered something cleaner, softer, smarter? Technology that vanishes by design, not because it's primitive, but because it's sustainable. Not because it's weak, but because it's intentional. Imagine machines that decompose after use, clothing that returns to soil, structures that reabsorb into the landscape. A civilization that leaves no trace because it chooses not to. Not a lack of intelligence, but the ultimate form of it. We often assume ancient technology must leave behind durable remnants, temples, tombs, tablets. But that assumption reflects us, our bias, our need to memorialize. But what if they saw impermanence as a virtue? What if their greatness was measured by how little they disturbed the earth, not how much they conquered it? If everything decomposes, how would we know they existed? We wouldn't find statues,
We wouldn't find coins. We wouldn't find bones wrapped in gold. We might find, at best, unusual soil chemistry, pockets of carbon alteration, changes in pollen and plant life patterns, a sudden uptick in ecosystem diversity or collapse. Barely there shadows in the dirt. Not enough for certainty, just enough for suspicion. Are we too focused on hard evidence? Think about this. We associate real with hard things: stone, steel, fossils. But the real story of life, of civilization, is often told through soft things: behavior, belief, balance. And those don't fossilize. So, maybe we're trying to weigh a ghost, trying to photograph a shadow. Maybe the very evidence we seek is the kind of evidence only intuition can notice. What if they lived with the earth, not against it? Our idea of progress is building up, but maybe theirs was blending in. We pave over rivers. They might have flowed with them. We rip open mountains. They might have cultivated forests. We create waste. They might have created harmony. And that kind of civilization, you wouldn't find it in museums. You'd find it in the absence of scars on the land. A civilization like that might have looked like untouched wilderness, when in fact, it was the most carefully tended garden the planet had ever known. So maybe we've walked through their ruins without realizing it, because there was nothing ruined. Only life, balanced, whole, and then gone.
The human echo, let's flip the lens. Let's stop asking, what if someone lived here before us? And start asking, what would we look like if we vanished tomorrow? Think about it. Let's say you hit the big red button. Poof, humans are gone. No more skyscrapers, no more TikTok, no more drive-through coffee, nothing. What happens? Well, first comes the decay. Cities crumble. Nature creeps in. Foxes move into office parks. Vines grow through billboards that used to scream, "Now on sale." But give it, a few hundred years? No more roofs. No more power grids. Just ruins. Now jump ahead 1,000,000 years. Yeah. Good luck finding your iPhone. And yet, not everything disappears. Because while your bones turn to dust, while your tweets get eaten by fungus, some things stay. Things we didn't mean to leave. Things we can't take back. Microplastics in the ocean. Carbon in the sky. Lead in the dirt. Isotopes in the ground from a time we thought it was cool to blow up atoms in the name of peace. Those are the fossils of our time. Not statues, not monuments, not golden records sent into space, but pollution, byproducts, chemical scars, tiny signatures in the Earth's skin whispering, something intelligent was here. They used fire. They shaped metal. They split atoms. Then they were gone. It's humbling, isn't it? You spend your life chasing meaning, trying to build something that lasts. But the planet doesn't care about your resume, or your followers, or your TED Talk. It keeps what it wants, and forgets the rest. So maybe the real question isn't, will we be remembered, but what do we want to be remembered for? Here's what's wild. Some of the clearest signals we'll leave behind are accidents. Concrete wasn't made to last forever, but it just might.
Plastic wasn't designed to be immortal, but it kinda is. The Anthropocene, the age we're in right now, isn't marked by our greatness. It's marked by our trash. How's that for a legacy? Now, let's be real for a second. This isn't about guilt. It's about awareness. Because once you realize that everything you do leaves a trace, you start living differently. You stop thinking like a tenant. You start thinking like a geologist. What will this choice look like in 100 years? 1,000? 1,000,000? Let's go even deeper. If some alien scientist lands on Earth 10 million years from now, what would they find? Not cities, not books, but an odd spike in CO2, synthetic chemicals no other species made, unusual radiation patterns, fossilized traces of chicken bones everywhere. Yes, chicken bones. Because the broiler chicken, engineered for fast meat, is now the most numerous bird on Earth. Think about that. Aliens won't know Shakespeare, but they'll know KFC. That's kind of hilarious, and tragic, and deeply human. So what's the point? The point is, we are temporary, but our impact is not. You can vanish, but your fingerprints stay. The Earth records everything. Not in selfies, not in poetry, but in carbon, in isotopes, in stone. And maybe, just maybe, that's the same story for someone who came before us. Someone who lived, burned bright, built wonders, and vanished. Not because they were dumb or evil or doomed, but because time is undefeated. And the planet, it forgets everyone eventually. So if you're reading this, if you're still here, don't waste it. Be kind. Be curious. Leave something better than trash. Because long after we're gone, long after our words fade, the Earth might still whisper, someone was here, and for a little while, they made something beautiful.
What if civilization wasn't technological at all? The possibility of philosophical or consciousness-based societies. Let's stretch the imagination again. What if a civilization's greatness wasn't measured by its cities, its machines, or its power grids, but by the depth of its mind? What if the most advanced society Earth has ever seen never split an atom, never launched a satellite, never carved its name into a mountain? Because it didn't need to. The mind as a frontier. We tend to equate advanced with technical. But why? Technology is just one path, one choice. What if another species walked a different trail? Not outward, inward. Instead of building rockets, they built inner peace. Instead of digital networks, they cultivated mental networks, ways of connecting that didn't need devices. Instead of storing data in machines, they memorized, recited, and passed on knowledge in ways we don't even understand. We think of progress as material, tangible, touch and see. But what if real evolution isn't something you can hold? What if it's how you experience, how you process existence, how you connect to others without words, without wires? Collective consciousness? Picture this. A civilization of individuals so deeply attuned to each other they can share feelings, memories, ideas directly. Not with language, not with tech, but with pure awareness. They wouldn't need cities. They wouldn't need documents. They wouldn't need monuments, because the monument was the mind.
a living, flowing archive carried by every member of the species. What would they leave behind? Nothing you could photograph, nothing you could carbon date. Maybe a shift in brainwave resonance across species. Maybe subtle genetic adaptations tied to emotional intelligence. Maybe nothing. Because the most powerful civilizations might burn brightest without a physical flame. Could we even recognize a consciousness-based civilization? Let's be honest. If we found a valley full of strange rock formations, we'd test the rocks. But would we test the feeling of being there? Would we consider that the very energy of a place might have been shaped by intelligent beings? Probably not, because our science isn't built for that. It's built for atoms and bones, not awe. But think about how we remember our own past. Our most treasured civilizations left behind music, ideas, languages, beliefs. And many of those aren't physical. They're vibrations, stories, philosophies. So maybe the question is wrong. Maybe we shouldn't ask, what did they build? Maybe we should ask, what did they understand? If a society chose consciousness over industry, they'd live simply, move lightly, and fade without a trace. And in that vanishing act, they'd leave behind something more valuable than stone. A question, a haunting, a tug on the edge of imagination that says, you're not alone in thinking deeply, not alone in seeking, not the first, maybe not the last. So when we search for past civilizations, maybe we shouldn't look down into the dirt. Maybe we should look inward. Because what if the real signal is not in the earth, but in us? In the way we dream, in the way we wonder, in the way we feel like we're remembering something we've never been taught.
The Great Forgetting. Why civilizations may rise and fall in cycles beyond memory. Here's a hard truth most of us don't think about. Forgetting is just as natural as remembering. And civilizations, just like people, can forget. Not because they're careless, not because they're weak, but because time doesn't care what you built, who you were, or how high you climbed. Time buries everything. Not all collapse is loud. We imagine the fall of civilizations as dramatic: war, plague, famine, disaster. But some falls are quiet. No fires, no blood. Just slowing, simplifying, drifting into myth. Until one day, no one remembers the language, or how the tools were made, or what the temples were for. And the stories that were once sacred become bedtime tales. History isn't a straight line. We like to think progress is a one-way street, that we start with nothing, discover fire, invent wheels, build the internet, and never look back. But what if that's just a story we tell ourselves? What if history is cyclical, not linear? What if civilizations rise, reach their peak, and fall? Over and over again, each one forgetting the last. The myth of the first. Every generation believes it's the first to do something. The first to fly, the first to split atoms, the first to build machines that think. But maybe we're not first. Maybe we're not even fifth. Maybe we're just the latest spark in a long chain of lights that keep getting snuffed out before they can become a flame that lasts. Memory is fragile. Think about this. The vast majority of our own history has been lost. Entire empires we only know by a name.
languages we can't translate, technologies we don't understand. And this is just from a few thousand years ago. So what about civilizations from 1,000,000 years ago? 10 million? Even if they were real, how could they possibly be remembered? Oral traditions can't outrun time. Stories are powerful, but they're fragile too. Told wrong once, a fact becomes a fable. Told wrong twice, a truth becomes a myth. Told wrong for 1,000 years, it disappears. And that's if the story even survives war, famine, or natural disaster. Most stories don't. The evidence may be in our myths. Here's a thought. Maybe the stories about ancient gods, golden ages, civilizations that fell from the sky, maybe they're not fiction. Maybe they're fractured memories, distorted echoes of something real. But time twisted them. Cultures changed them. So now we read them as fairy tales. When maybe, just maybe, they were warnings. The past doesn't always leave clues. We expect ruins, but what if the past doesn't always leave bones and bricks? What if it leaves shadows, a strange layer in the soil, a genetic anomaly, a feeling that something is missing? That's the cruel joke of time. It's the greatest eraser ever made. What if we're meant to forget? Let's go deeper. What if forgetting is part of the cycle? What if civilizations are supposed to fall so new ones can grow? What if forgetting isn't failure, but renewal? Like a forest burning down so it can bloom again. So the real question isn't, are we the first civilization? The real question is, will we be the first to remember?
The civilizations that vanished themselves. What if disappearance wasn't failure, but a feature? What if some civilizations didn't collapse, they opted out? We tend to think in linear progress. Stone Age, Bronze Age, Industrial Age, Digital Age, Space Age. Up and up, faster and faster, always building, always expanding. But that's our story. It doesn't have to be everyone's. Picture a civilization with technology we can't imagine, not because it's too advanced, but because it's too subtle. A culture that discovered energy not through combustion, but through harmony. One that saw growth not as expansion, but as refinement. They wouldn't build towers, they'd build balance. Not skyscrapers, but serenity. And maybe after thousands of years they reached a tipping point, not of collapse, but of enlightenment. They stopped mining, stopped burning, stopped conquering. They began dissolving, not out of weakness, but out of wisdom. Think about it. What happens when a civilization masters the art of enough? Enough food, enough knowledge, enough meaning. Would it still strive for more? Or would it disappear, intentionally? What if the final step in evolution is not to leave behind monuments, but to leave behind no damage? To become so integrated with nature that your fingerprint is no heavier than a breeze. We assume disappearance is failure, collapse, tragedy. But what if it's transcendence? What if vanishing without a trace is the greatest legacy? Imagine that, a species that learns to live lightly and then lets go. No war, no fire, no scream. Just stillness and silence.
We wouldn't recognize them in the rocks. We wouldn't hear them in the wind, because they didn't leave a mess. They left a choice. To not dominate, to not outlast, to simply be, and then be no more. Now flip the mirror. What will we leave behind? A skyline of broken glass? A crust of plastic and lead? Or will we learn, maybe too late, that the deepest wisdom is not to build louder, but to fade smarter? The irony of the Anthropocene is that our civilization might be the most visible and the most forgettable. Visible because of the scars, forgettable because of the fragility. You see, burning forests and melting ice might mark our presence today, but the Earth has ways of healing what we thought permanent. She always has. So here's the uncomfortable thought. We search for past civilizations with the assumption that we are the standard. But maybe, just maybe, the ones that came before us were smarter because we can't find them. Because they knew better than to leave a mess. Because they learned what we still resist, to live lightly and exit gracefully. Are we listening? Or are we too busy shouting our existence into the void?
Silent warnings. What extinction events might reveal about lost civilizations? Let's imagine a signal. Not a radio broadcast, not a monument, but a sudden silence in the record of life. An extinction. A massive global collapse. What if that silence, that break in biodiversity, wasn't just nature? What if it was the echo of intelligence? A civilization that went too far and vanished. When life suddenly stops. The Earth has seen 5 major extinction events. Each one brutal. Each one world-changing. The end Permian wiped out over 90% of marine species. The end Cretaceous took the dinosaurs. But not all extinctions are caused by asteroids or volcanoes. Some are still mysteries. Could one of them be artificial? Not from alien invasion, but from a civilization that disrupted its own biosphere, like we're doing now. The smoking gun that isn't. We look for soot. We look for iridium. We look for shock quartz, evidence of asteroids. But what if we missed the real clue? What if a past civilization burned fossil fuels, triggered climate change, or altered the atmosphere in a way that erased not only themselves, but the record of their own existence? We wouldn't find a city. We'd find a spike in CO2, a dip in biodiversity, a strange anomaly in sediment layers, just like we're leaving now. The Earth doesn't keep secrets. It forgets them. Our planet isn't a museum. It's a washing machine. It grinds, it melts, it recycles. Fossils are rare. Complete records are impossible. And time is relentless. Give it long enough, and it'll turn an empire into compost. So when we see a mysterious extinction, a sudden drop in species, That might not be the start of a story. It might be the end of something we'll never know. Are we repeating a pattern? Maybe we're not the first to stand at this edge. Maybe there was another species, intelligent, industrial, creative, that pushed their world too far. Maybe they saw it coming, tried to fix it, or fled. And maybe they didn't make it. But their end became someone else's beginning. Life rebooted, the slate wiped clean, and evolution tried again, this time with us. The silence between the stars and beneath our feet. We often talk about the Fermi paradox. Where is everybody? Why don't we see signs of alien life? But what if the real paradox isn't out there? It's right here. What if Earth has been a stage for more than one great act? And we're just the latest performers on a planet that resets the show every few 100 million years. A warning or a whisper? Extinction events aren't just endings. They're messages in the layers. Not in words, but in patterns, in gaps. They whisper, something went wrong here. Something disappeared. Something was lost. And maybe if we listen carefully, we'll realize the warning wasn't meant for the past. It was meant for us.
A civilization in disguise. Could a past advanced society have looked nothing like ours? When we imagine advanced civilizations, we picture us. Skyscrapers, satellites, cars, code. Technology with wires and circuits, industry with smoke and steel. But that's just one path. One very human, very specific path. What if intelligence doesn't always look like ours? What if it evolved differently? What if they didn't build? Imagine a civilization that didn't rely on construction. No concrete, no metal tools, no burning of fossil fuels. What if they lived in perfect harmony with their environment? No cities, no machines, no pollution. They could have been incredibly advanced, philosophically, intellectually, even scientifically, but without ever disturbing the earth in the way we do. Would we be able to tell? Would there be anything left to find? Tools we can't recognize. We define tools by what we know. A hammer, a wheel, a microchip. But what if their tools weren't physical? What if they used sound, light, or biology? What if they engineered bacteria to build for them, or communicated through complex sense or magnetic fields? To us, it would seem like magic, or worse, like nothing at all, because we're only looking for our own fingerprints. Intelligence doesn't mean industry. Here's a strange thought. What if intelligence isn't always ambitious? What if there was a civilization that never wanted to grow? Never wanted empires or expansion or conquest? They could have been brilliant, but reclusive, careful, introspective. They might have understood things we can't even imagine, but left no scars on the earth, no bones, no ruins. And that's the thing. Our idea of civilization is shaped by activity,
But maybe some civilizations are shaped by awareness, and awareness doesn't always leave a mess. Biology over machinery. What if a civilization evolved not by building machines, but by rewriting themselves? Bioengineering instead of hardware. They didn't invent tools, they became tools. Imagine a species that could grow memory into its cells, that could manipulate energy through biology, not wires or buttons. What would they leave behind? Nothing we'd recognize. Maybe nothing at all. Could they still be here? This is a wild one. What if they didn't go extinct? What if they went inward, into oceans, into caves, into dimensions we haven't discovered yet? We assume they're gone, but maybe they just stepped sideways, out of our view, out of our reach. And maybe they're watching, wondering if we'll make it through the phase they already lived through. Evolution isn't done with us. We act like we're the final product, like human intelligence is the top of the ladder. But evolution doesn't have a finish line. It just keeps going. Maybe we're still early. Maybe there have been others. Maybe we'll be replaced too, by something gentler, or stranger, or more aware. The mirror we can't see. When we ask, are we the first? What we're really asking is, are we alone in time? But time doesn't care about ego, and history isn't written in stone. It's written in traces, and some traces are invisible to the tools we've built. So maybe the greatest mystery isn't what's out there. It's what's behind us.
For most of that time, Earth had no humans or even mammals. And here's something even wilder. Not only have humans been around for just the last second of Earth's clock, for most of that time, Earth didn't even have humans, didn't even have mammals. That's right. If you rewound the tape of life back a few 100 million years, you wouldn't just find a world without people. You'd find a world that wouldn't even recognize mammals as a thing. No dogs, no whales, no monkeys, no us. Let's break it down. Earth is 4.5 billion years old. Mammals? They didn't really start to flourish until after the dinosaurs died, about 66 million years ago. That means for roughly 3.5 to 4 billion years, there were no warm-blooded, fuzzy creatures nursing their young. Just microbes, and then fish, then bugs, then reptiles, and finally, dinosaurs ruling the world for 100 million years straight. And we, humans, only evolved about 200,000 years ago. That's a drop in the ocean. So for the vast majority of Earth's history, nothing like us existed, not even close. That's what makes this question so fascinating, because if something intelligent did evolve back then, before mammals, before us, it wouldn't look like us. It wouldn't think like us. It might not even leave behind the kinds of tools or structures we'd expect. But it could still have been real. And in a planet that's been alive for billions of years, that's seen extinction after extinction, rise after fall, who's to say we're the only ones who ever figured things out? The planet doesn't preserve everything. Wood decays, metal rusts, bones dissolve. Here's something we don't think about enough. We walk around on this Earth like it's a giant archive, like it's keeping records for us, saving all the things we build and do. But the truth is, it's not. This planet, it doesn't preserve everything. In fact, it tries really hard not to. Let me put it this way. Earth isn't a museum.
It's more like a constant demolition zone. Wood decays. Even the strongest, toughest wood, oak, mahogany, teak, you leave it outside long enough, it'll rot. Rain seeps in. Fungi and bacteria break it down. Termites come in like tiny wrecking crews. And before you know it, it's gone. Completely. Now imagine something made of wood from 5,000 years ago. Already rare, already fragile. Now stretch that to 5 million years. Yeah, no chance. Metal rusts. Even metals we think of as strong, iron, steel, even copper, they don't last forever. Exposed to moisture, oxygen, and time, they corrode. They break down. They flake into nothing. Ancient tools made of iron that are just a couple thousand years old are often already half-eaten, barely recognizable. Now imagine a metal tool that's 50 million years old. You won't find it in a museum because it likely doesn't exist anymore, unless it was sealed in a vacuum, protected deep underground, and even then, we're talking about extreme luck. And bones? We think bones last forever, but they don't. They're fragile, they're porous, and unless they're fossilized, which is rare, they dissolve. Most living things that die, they don't fossilize. They rot, they're eaten, they're crushed, burned, buried, and forgotten. Even when fossilization does happen, it needs the perfect storm. Rapid burial, low oxygen, mineral replacement, stable conditions over millions of years. Most of Earth's living history, it's been erased. So here's the big idea. If you're hoping to find clear, solid evidence of an ancient civilization, something that's 100 million years old, you're asking for a miracle. You're asking for something to survive the full force of time, nature, and geology. And Earth doesn't make that easy. Think about it. How many buildings do we have from just 500 years ago? A few castles, some temples, a crumbling wall here and there. Now remove humans, remove maintenance, give nature a few hundred years. It all goes away. Vines crack the foundations. Trees grow through walls. Wind, rain, frost, year after year, layer after layer. 1,000 years from now, your house is dust. 10,000 years? There's no trace you were ever there. And that's assuming nothing major happens. No earthquake, no flood, no volcanic eruption. Now multiply that by 1 million. So what does that mean? It means we can't expect time to hand us neat little fossils of skyscrapers or buried smartphones. If there was ever a civilization before us, something ancient, intelligent, industrial, the evidence wouldn't be obvious. It wouldn't be sitting on a mountaintop with a "Welcome to Ancient City" sign. It would be scattered, subtle, deep. Maybe a weird layer of carbon-rich sediment. Maybe a spike in rare metals. Maybe a chemical anomaly that doesn't match any known natural process. Because that's all that might survive. Not the buildings, not the machines, not the people. Just echoes in the earth. And that's kind of haunting, isn't it? To think that a whole civilization, maybe even one like ours, could rise, flourish, and vanish, and leave almost nothing behind. No monuments, no statues, no stories, just a strange bump in the rock record, a chemical whisper in a core sample. And if that's all they left, if they were real, then what does that say about us? Because we're building skyscrapers now, we're laying highways, launching satellites, sending signals across the stars, but give it a few million years, Earth will chew through all of it. Concrete will crack, steel will rust, plastics may last a while, but even they break down eventually. And when the continents shift, when oceans rise, when glaciers return and scrape the land clean, will anything we built still be here? Will anything say, humans were here? This is why scientists aren't looking for giant ruins. They're looking for clues, patterns, anomalies, because they know Earth isn't kind to history. She buries it, burns it, forgets it. And that means if someone came before us, they may have already been forgotten.
The final question. Are we the first, or just the first to ask? Let's strip everything away. Forget the ruins, forget the isotopes, forget the sediment and the sea. Let's ask the question that haunts this entire journey. Are we really the first? Not the first species, not the first to walk upright, build cities, send satellites into orbit, but the first to wonder. Are we alone in time? Civilization as a moment, not a destiny. We tend to think of civilization as inevitable, like it had to happen, like it was always coming, like once life began, it was only a matter of time before cities rose and machines hummed. But the truth is, civilization might be a fluke, a 1 in a billion accident, a fire that sparks once and dies in silence. Maybe this has happened before. Maybe intelligence isn't rare. Maybe it's common. But maybe it doesn't last. Maybe intelligent life blooms like a flower, brief, beautiful, fragile, before the winds of time tear it apart. A species builds, explores, reshapes the world, and then collapses, gone before the next one arrives. And the Earth, with its tides and tectonics, wipes the slate clean. Again, and again, and again. The ghosts will never meet. Think about it. If a civilization reached our level 100 million years ago, how would we know? No bones, no buildings, just faint traces, chemical echoes buried under continents, smeared by shifting seas. They might have asked the same questions. They might have searched the stars. They might have built wonders we'll never see. And then, silence. The humbling truth. Maybe we're not the first. Or maybe we are. But either way, the message is the same. Nothing lasts forever. Not even the smartest species on the planet. The Earth is patient. It has time. It will outlive us, just as it may have outlived others before us. Curiosity as survival. So what do we do with this knowledge? We could ignore it, laugh it off, say, cool theory, and move on. Or we could take it seriously, because the fact that we might not be the first doesn't make us less special. It makes us more responsible. We're not just writing our own story. We're writing the next chapter in a book that could have ended long ago. And how we act now might determine whether there's ever a reader to discover what we left behind. The echo that matters. Maybe no one will ever find our skyscrapers, or our smartphones, or our songs. But maybe, just maybe, someone, someday, will find that line in the rock. That strange shift in carbon. That whisper of plastic. That shimmer of plutonium. And they'll say, someone was here. Someone tried. Someone mattered. So no, we may never know if we were the first. But we still have a choice.
to be the first to leave something worth remembering, even if no one ever does.
Memory in the sky. Could Earth's atmosphere keep secrets the ground forgot? You can bury ruins. You can grind bones into dust. You can sink whole continents beneath the waves. But the sky? The sky remembers. Not in photographs, not in stories, but in chemistry. Because long after the machines have rusted and the buildings have crumbled, the atmosphere still carries the scars. The air doesn't lie. Every time we burn something, coal, oil, gas, we change the balance of the air. Not just with smoke, but with carbon. Specifically, carbon isotopes. Industrial carbon has a signature, a chemical fingerprint, a ratio of carbon-13 to carbon-12 that says, this didn't come from nature. And that signature? It lingers. A line in the sky. Imagine the Earth 10 million years from now. The cities are gone, the language forgotten, the culture erased. But geologists of the future, whatever species they might be, drill deep into ancient ice cores or into layered sediment at the bottom of an ancient lake, and they find it. A line. Sharp. Sudden. Undeniable. Right there in the chemical memory of the planet is proof that something once altered the atmosphere on a global scale. They won't find our poems, but they'll find our exhaust. Radioactive whispers. We also left behind other whispers. Radioactive isotopes, like plutonium-244, not naturally occurring in significant quantities, only made in reactors or bombs, buried in layers of soil, washed into oceans, scattered across deserts, invisible to the eye, but loud to a Geiger counter. And they last thousands of years, even longer. If someone or something knows what to look for, our radiation trail tells a story, one of fire and power, and a species that once split the atom just to see what would happen. Atmospheric disruption. We've raised the levels of carbon dioxide. We've changed the nitrogen cycle. We've added ozone-depleting chemicals, microparticles, and smog that clings to mountaintops. Even after we're gone, those shifts may persist. In glaciers, in tree rings, in sediments untouched by erosion. The air records our ambition and our excess. Past echoes in the present. Here's the twist. We've already seen oddities in Earth's past. Sudden jumps in CO2, rapid warming, ocean acidification, mass extinctions. The Paleocene-Eocene thermal maximum was one such event. About 56 million years ago, Earth's climate spiked. Carbon levels surged, temperatures rose, species vanished. Sound familiar? Scientists debate the cause. Volcanoes? Methane releases? But what if, just what if, there was another reason? What if PETM was Earth's last industrial age, a previous Anthropocene? No proof, just questions, but meaningful ones. We're writing our own layer. Every car, every factory, every plane flight, every power plant. It's all writing a story into the atmosphere, and it will outlast us. Our atmosphere is not just air, it's memory. And one day, someone else may read it. Someone who has no idea what we looked like, no clue what we believed. But they'll know we were here, because the sky told them so.
The ocean's vault. What lies beneath may never be known. If Earth has a memory, the ocean is where it hides the darkest parts. Not under rocks, not in ruins, but beneath the waves. In a world more vast, more alien than anything we've ever explored. We've mapped more of Mars than we have of our own seafloor. And that's not a coincidence. The ocean doesn't just cover secrets. It erases them. A landscape that rewrites itself. Think about this. The average age of the ocean floor is just 200 million years. That's nothing. A blink. Why? Because the ocean recycles itself. Seafloor spreads at mid-ocean ridges. It sinks back down through subduction zones. It's born, it dies, it vanishes. Over and over again. If anything was built there, a city, a port, a civilization, it's been swallowed whole. Melted, crushed, forgotten. Water, the great eraser. Land preserves. Water destroys. On land, ruins can survive for centuries, even millennia if conditions are just right. But underwater? Salt, pressure, currents, they tear everything apart. Metal corrodes. Wood bloats and splits, stone cracks from the cold. And if it sinks deep enough, the weight alone will crush it into nothing. Lost in the depths. If a past civilization existed near coastlines, chances are it's gone now. Because coastlines aren't fixed. They shift, they flood, they vanish. The end of the last ice age raised sea levels by over 100 meters. Entire landscapes, plains, forests, river valleys now lie underwater. And we haven't even looked. Not really. Archaeology beneath the sea? It's painstaking, expensive, dangerous. And most of the ocean floor? It's just too deep. Out of reach. Out of sight. Out of history. A vault we can't open. The ocean might be Earth's greatest archive, but we have no key. We don't know where to dig. We don't know what to look for. And even if we did, the layers are too thick, the clues too fragile. The deeper you go, the harder it is to distinguish what's natural from what's not. A metal alloy could be natural. A strange mineral pattern could be volcanic. And even if you find something odd, you're fighting time, pressure, and skepticism. What if the answers are drowned? We search deserts, we scan the stars, but maybe the answers, the real unsettling, humbling answers, are beneath our feet. Underwater, buried in silt, crushed beneath tectonic plates, washed clean by currents that never stop moving. We may never know if another civilization came before us, not because they didn't exist, but because the ocean buried their bones too deep. And maybe that's its role. Not just to give life, but to take it back and seal it away.
Subduction, parts of the ocean floor are pushed under continental plates and melt, erasing any traces on them. All right, now we're getting into the final act of Earth's disappearing trick. If erosion wears things down, if sedimentation buries them, if tectonics crush and reshape, then subduction is the moment the planet says, "Thanks for playing, now let's melt you down and start over." So what is subduction? It's when one tectonic plate, usually oceanic, is shoved underneath another, usually continental. And when I say shoved, I mean slow motion violence. Picture two massive slabs of the Earth's crust colliding, but instead of bouncing off each other, one dives beneath the other and disappears.
deep into the earth, into the mantle, where things get hot, really hot. And here's the kicker. Everything on that slab, everything that was on that patch of seafloor goes with it. Sand, mud, fossils, chemicals, rock layers, entire landscapes, even traces of ancient life, gone, melted, recycled, turned back into magma. And eventually, that magma might rise again, in a volcano, thousands of miles away, in a totally different form. The past gets reincarnated without memory. So why does this matter? Because a huge chunk of Earth's surface, especially the ocean floor, isn't permanent. It's always moving, always being created at ridges and destroyed in trenches. You know those deep ocean trenches? The Mariana Trench, the Peru-Chile Trench? That's where subduction happens. That's where entire sections of the Earth disappear. And that means if any civilization, any species, any intelligent life ever lived on a continent or island that sat on top of an oceanic plate, there's a good chance their entire world has been swallowed, burned, erased. Let's make it real. Imagine there was an advanced species living 150 million years ago. Maybe they built coastal cities. Maybe they explored islands we no longer see. Maybe their greatest monuments sat by the sea. Now fast forward. Tectonic plates shift. The ocean floor underneath them starts sinking. It slides under another plate. And over millions of years, it descends into the mantle. Temperature rises, pressure builds, solid rock becomes liquid fire. And everything that once existed on that piece of Earth vaporized forever. So, when people ask, if someone came before us, where are their ruins? One answer is simple. They might have been eaten by the planet. Not hidden, not buried, destroyed on a geological level. Subduction is nature's reset button. It doesn't care if you were the most advanced species in history. It doesn't care what you built, what you dreamed, what you left behind. If your land was in the wrong place, it's gone now. And maybe that's the most humbling part of this whole idea. Because we think of Earth as a home, as stable, as ours. But truth is, Earth isn't just a home. Earth is a machine. And everything on the surface, just raw material waiting its turn in the cycle.
Erosion and weathering. Rain, wind, frost, heat slowly chip away at anything exposed. Let's talk about the slow killers. Not explosions, not volcanoes, not apocalyptic fireballs from space. I'm talking about the quiet stuff, the everyday stuff, the stuff we barely notice because it's always there. Rain, wind, frost, heat. The elements. These are the real erasures, the relentless sculptors, the forces that never stop working. Rain seeps in, through cracks, between bricks, under foundations. It softens, it washes, and over time it dissolves. Wind? It scours. It lifts grains of sand and flings them at rock, at metal, at anything standing tall. Tiny hits, thousands, millions, and eventually even stone gives in. Frost, that's a quiet assassin. Water gets into a tiny crack, freezes, expands, and breaks it open. Repeat that for centuries, that crack becomes a canyon. Heat is no less ruthless. It expands metal. It dries out wood. It makes materials expand, contract, warp,
and fail. And when all four, rain, wind, frost, heat, team up, they turn monuments into ruins, skyscrapers into skeletons, entire cities into piles of forgotten stone. Not in a week, not in a year, but over decades, centuries, millennia. It's slow, but it never sleeps, never stops. You leave anything out long enough, a statue, a road, a building, even a mountain, and nature will wear it down, bit by bit, layer by layer, until there's nothing left to recognize. Now, take that slow destruction and give it 1,000,000 years, or 100. Ask yourself, what survives? What could possibly withstand that kind of slow-motion attack? Even the pyramids, our forever monuments, wouldn't make it that far if left to the elements. They'd erode, crumble, get buried, get lost. So if an ancient civilization left anything behind, anything exposed to the surface, it's gone. Rain took it. Wind blew it away. Frost cracked it open. Heat baked it to dust. And that's just the beginning of what time can do. In just a few centuries, buildings become ruins. In a few million years, the surface changes completely. Let's talk timelines. Because if you think things on Earth stick around forever, you haven't been paying attention. In just a few centuries, buildings become ruins. That's not exaggeration, that's fact. You leave a skyscraper alone, no maintenance, no people, no protection, and nature takes over fast. Vines creep in, water leaks, foundations shift, animals move in. Within 100 years, it starts looking haunted. 200, the roof's gone. 300, it's barely recognizable. Give it 500 years, it's a pile of stone and rust. Now, zoom out even further. 1,000 years, that neighborhood, gone. Buried under soil, trees, maybe even a whole forest. Now take that same idea and stretch it to 1,000,000 years, and then to 10 million, or 100 million. At that point, we're not even talking about ruins anymore. We're talking about new geography. Because Earth doesn't just age, it reshapes itself. The surface you're standing on today could be the bottom of an ocean in a few million years. That mountain range could be ground flat by wind and rain. That desert might become a swamp, a jungle, a frozen wasteland, or part of a continent that doesn't even exist yet. Over deep time, the planet shifts, literally. Plates move, rivers reroute, volcanoes erupt, glaciers scrape. Everything changes. So if a civilization built something long ago, and then time rolled on for a few million years, the surface they once lived on may not even exist anymore. It may have been swallowed, crushed, recycled. It's not that we miss the ruins, it's that the ruins don't exist anymore. They've been erased, not by some cover-up, but by the Earth itself. So yeah, it only takes a few hundred years for our world to fall apart, but it only takes a few million for the entire surface of the planet to become someone else's world.
Subduction, parts of the ocean floor are pushed under continental plates and melt, erasing any traces on them. All right, now we're getting into the final act of Earth's disappearing trick. If erosion wears things down, if sedimentation buries them, if tectonics crush and reshape, then subduction is the moment the planet says, "Thanks for playing, now let's melt you down and start over." So what is subduction? It's when one tectonic plate, usually oceanic, is shoved underneath another, usually continental. And when I say shoved, I mean slow motion violence. Picture two massive slabs of the Earth's crust colliding, but instead of bouncing off each other, one dives beneath the other and disappears deep into the Earth, into the mantle where things get hot, really hot. And here's the kicker. Everything on that slab, everything that was on that patch of seafloor goes with it. Sand, mud, fossils, chemicals, rock layers, entire landscapes, even traces of ancient life, gone, melted, recycled, turned back into magma. And eventually, that magma might rise again, in a volcano, thousands of miles away, in a totally different form. The past gets reincarnated without memory. So why does this matter? Because a huge chunk of Earth's surface, especially the ocean floor, isn't permanent. It's always moving, always being created at ridges and destroyed in trenches. You know those deep ocean trenches? The Mariana Trench, the Peru-Chile Trench? That's where subduction happens. That's where entire sections of the Earth disappear. And that means if any civilization, any species, any intelligent life ever lived on a continent or island that sat on top of an oceanic plate, there's a good chance their entire world has been swallowed, burned, erased. Let's make it real. Imagine there was an advanced species living 150 million years ago. Maybe they built coastal cities. Maybe they explored islands we no longer see. Maybe their greatest monuments sat by the sea. Now fast forward. Tectonic plates shift. The ocean floor underneath them starts sinking. It slides under another plate. And over millions of years, it descends into the mantle. Temperature rises, pressure builds, solid rock becomes liquid fire. And everything that once existed on that piece of Earth vaporized forever. So, when people ask, if someone came before us, where are their ruins? One answer is simple. They might have been eaten by the planet. Not hidden, not buried, destroyed on a geological level. Subduction is nature's reset button. It doesn't care if you were the most advanced species in history. It doesn't care what you built, what you dreamed, what you left behind. If your land was in the wrong place, it's gone now. And maybe that's the most humbling part of this whole idea. Because we think of Earth as a home, as stable, as ours. But truth is, Earth isn't just a home. Earth is a machine. And everything on the surface, just raw material waiting its turn in the cycle.
Out-of-place artifacts, ooparts, objects supposedly found in ancient geological strata, mostly explained as misidentifications or natural formations. So let's talk about one of the most controversial and misunderstood ideas out there, out-of-place artifacts, or as the internet loves to call them, ooparts. You've probably seen them pop up in some late-night documentary or that friend's social media post with captions like, ancient microchip found in 500-million-year-old rock, or machine screw embedded in a fossil, proof of ancient technology. Sounds wild, right? But let's slow down. What are these things actually? Ooparts, short for out-of-place artifacts, are objects people claim were found in geological layers so ancient they shouldn't possibly be there. Think about it. A tiny metal sphere in 2-billion-year-old rock, a screw-shaped imprint in stone dated to the Jurassic era, a spark plug found inside a hunk of petrified clay. If true, these things would blow up everything we know about history, evolution, and civilization. But here's the thing.
Most OO parts aren't what they seem. Let's break it down. First, misidentification. Nature is really good at making things that look artificial. Seriously, there are crystals that look like tools, fossilized shells that mimic gears, mineral veins that form perfect spirals. Even bacteria can leave behind patterns that look like carvings. So when someone finds something odd in a rock and says, "This is a mechanical part," a good geologist usually steps in and says, "Or it's just manganese oxide." And 9 times out of 10, it is. Then there's the issue of contamination. Many of these discoveries were made before modern dating techniques existed. Tools weren't sterilized. Dig sites weren't secured. A modern nail could easily get into a chunk of ancient sediment, especially in mines, quarries, or places with mixed deposits. The so-called London hammer, a famous OO part found inside a rock-like nodule, turned out to be a 19th century tool that probably got encased in a concretion, a natural cement made of minerals, over time. That's not proof of an ancient civilization. That's just geology doing weird geology things. But let's be honest, the reason OO parts are so seductive isn't because they're convincing. It's because they tap into a deep, emotional longing. We want there to have been something before us. We crave mystery. We like to imagine a lost world of thinkers and builders long forgotten, leaving behind subtle clues that only the curious will notice. It makes life feel bigger, doesn't it? It tells us we're part of a cycle, that maybe we're not the peak of progress, but just another chapter in a very old book. Still, science demands more than mystery. It demands rigor. Because if we're going to seriously ask whether a civilization existed millions of years before us, we need evidence that holds up under microscopes, carbon tests, isotope analysis, peer review, and brutal skepticism. That's the standard. Not, "It looks like a gear," not, "I found it in a rock," not, "It's too perfect to be natural." And here's something else to consider. If there was a civilization before us, truly advanced, truly industrial, would they have left behind tools like ours? Hammers, screws, spark plugs? Or would their tech look nothing like ours? Made of biodegradable materials, non-metallic systems, or even purely digital, ethereal, or embedded in biology? What if they were post-metal? What if they lived underground or underwater? What if their legacy isn't in tools, but in chemistry? That's why scientists exploring ancient civilizations are no longer focused on physical artifacts. They're looking for chemical fingerprints, isotopic anomalies, global shifts in carbon ratios, synthetic polymers in ancient sediment, things that can't be chalked up to chance or the quirks of erosion. Because unlike gears or nails, chemistry doesn't lie. So, does that mean all OO parts are hoaxes or mistakes? Not necessarily. Some are still unexplained. A few are genuinely puzzling, and those are worth a second look. But they're not proof. They're just questions. Questions that invite better tools, sharper eyes, and a deeper understanding of the planet's deep past. In the end, OO parts are a mirror. They reflect what we want to believe. But if we want truth, we need to dig deeper, not just into the ground, but into the data, the layers, the science. Because the real answer might not come in the shape of a screw or a hammer. It might come in a molecule, or a missing pattern, or a silence that speaks louder than any artifact ever could. Chemical anomalies. Abrupt global isotopic excursions in rock could suggest industrial activity, but often have natural causes. Let's talk about rocks. Not just any rocks, ancient ones. Rocks that remember. Rocks that record. Because here's something most people don't realize. The Earth keeps a journal, not in words, but in layers. Each layer of sediment, each slice of shale, each band of limestone is like a page in a cosmic diary. And the ink? It's chemical, elemental, isotopic. Now imagine this.
You're a geologist cracking open a core sample from 55 million years ago. Everything looks normal until suddenly it doesn't. A sharp jump in carbon-12, oxygen ratios all out of whack, nitrogen signatures twisted like they've been tampered with. And you ask yourself, what happened here? Was it a volcano? A comet? Or was it something more? That's where chemical anomalies come in. Sudden, dramatic changes in the ratios of stable isotopes, carbon, nitrogen, oxygen, show up in the geological record like red flags. They scream, something big went down here. And when those shifts are global, not just in one core sample, but in sediments on every continent, you know you're looking at a planet-wide event. Now here's the twist. Some of these anomalies look a lot like what humans are doing right now. Burning fossil fuels? That increases carbon dioxide, but it also leaves behind a chemical signature. Less carbon-13, more carbon-12. Mass deforestation changes the nitrogen in soil and air. Industrial farming jacks up ammonia and nitrates. So if we were to vanish tomorrow, future geologists might find that sharp line in Earth's record and say, whoa, something intelligent was here. So now flip that idea. If we find a similar line 100 million years ago, should we wonder if someone else was once here too? That's exactly the kind of thinking behind the Silurian Hypothesis, and it's what makes these anomalies so important and so tricky. Because for every spike in carbon or drop in oxygen that might whisper civilization, there's a very loud natural explanation saying, actually that was a volcano, or a methane release, or a rapid climate shift, or the Paleocene-Eocene thermal maximum, a time when the planet heated like a fever and carbon levels surged, no cities or cars required. That's the problem. Nature can mimic industry. The Earth can fake a factory's fingerprint. Volcanoes can dump megatons of CO2. Methane clathrates can melt and send carbon chaos across oceans. Even asteroid impacts can change isotope levels overnight. So if we want to ask, did a past civilization burn fuel, run factories, farm on a global scale, we have to prove that the spike we're seeing can't be natural. And that's a brutal standard. Still, there are patterns that make scientists pause, anomalies that don't line up neatly with volcanic records or biological extinctions. For example, what if we found a sharp carbon spike without the expected rise in volcanic ash? Or an oxygen dip that lasts too long for a natural event? What if it's paired with traces of synthetic chemicals or rare metal ratios that don't belong? That's when the whispers get louder. But let's not get ahead of ourselves. Most anomalies, so far, have been chalked up to nature, not technology, not lost empires. But we're still learning, still refining our tools, still asking better questions. Because what if we're just not looking the right way? What if we're missing subtle patterns, not in the shape of artifacts, but in the storyline of isotopes? Think of it this way. If someone burned oil millions of years ago, the Earth wouldn't keep their skyscrapers, but it might keep their smoke. Buried deep in clay and coal and limestone, a chemical echo of intelligent life. And that's why these anomalies matter. They're not smoking guns. They're breadcrumbs. Little clues that say, something strange happened here. Look again. So here's the real challenge. Can we train ourselves to tell the difference between a volcano's roar and a civilization's whisper? Can we find that one anomaly that doesn't have a natural cause? And if we do, will we recognize it for what it is? Because here's the haunting possibility. Maybe we've already seen it. Maybe some anomaly in a dusty lab report wasn't from a volcanic winter, but from a forgotten...
Biggest challenge? Distinguishing artificial signs from natural processes. Volcanoes, methane releases, Paleocene-Eocene thermal maximum. All right, let's say you're a future geologist. Millions of years from now, you're digging into a chunk of Earth's crust, and you notice something weird. A sudden spike in carbon dioxide, a warming event. species die off, weird chemical residues in the soil. Sounds familiar, right? But here's the kicker. How do you know whether it came from a civilization or just a volcano? That's the hardest part of this whole idea, because Earth is no stranger to chaos. She's been through mass extinctions, global firestorms, frozen hellscapes, methane belches, and volcanic tantrums that blacken the sky for years. The Earth can wreck herself without our help. So, if we find strange chemical anomalies in ancient rocks, carbon spikes, isotope shifts, traces of metals, how can we tell if it was us, or someone like us, or just Earth doing her thing? Take the Paleocene-Eocene thermal maximum, or PETM for short. It happened about 56 million years ago. Suddenly, the planet got way hotter, like fast. Carbon levels spiked, oceans acidified, ecosystems changed almost overnight. No cities, no machines, no factories. As far as we know, no humans, no civilization, just nature going wild. Maybe it was methane released from under the ocean. Maybe volcanic activity cracked open the crust. Maybe both. But if you were looking at that in the rock record without knowing the backstory, it could look a lot like today. See the problem? Now, flip it around. Let's say there was a civilization before us. They burned fossil fuels, they changed the climate, their species disappeared, and the only things left behind were a carbon spike, some metal traces, and a drop in biodiversity. How would that look different from PETM or any other natural event? That's why this question is so tricky, because the planet doesn't label her layers. There's no giant sign that says, hey, this was caused by intelligent life. Instead, we're left with clues. Tiny, fragmented, worn-down traces, chemical echoes, sediment whispers, and our job? To read the difference between chaos and design. Let's break it down even more. When we talk about artificial signals, we mean things like isotope ratios that don't align with known natural processes, rare earth metals concentrated in unusual ways, synthetics, plastics, polymers, chemicals that don't occur in nature, radioactive residues from nuclear tech, and patterns, repeating global patterns that suggest intelligent coordination. But here's the thing. Some natural events can mimic those patterns. Volcanoes can throw out heavy metals. Methane bursts can shift carbon ratios. Lightning strikes and meteorites can even create tiny glass spheres or fuse soil into odd shapes. Nature can be messy and clever. So, is there anything that screams, this was made by minds? Maybe, but it has to be something that nature wouldn't or couldn't do on her own. Like what? Maybe it's a type of plastic that never degrades. Maybe it's a metal alloy that never forms in stars. Maybe it's a layer in the Earth's crust that holds traces of multiple anomalies, tied together in ways that don't match any known natural cause. Not just one weird signal, but a cluster of them, spread across the globe, synchronized, unnatural. That's what scientists would look for. That's what we are leaving behind right now. Because here's the uncomfortable truth. The line between civilization and catastrophe is razor thin, and in the geologic record, they can look the same. Which means, if we really want to know whether we were first, we have to be ready to see signs that aren't just obvious, not pyramids, not buried cities, but chemical ghosts, encoded in the crust. And if we ever find them, we'll have to ask the toughest question of all. Is this us, or was it someone else? Most persistent signs are chemical. Changes in atmospheric composition, sediments, and soil due to extraction, production, fuel burning. You know what's funny? The strongest thing a civilization leaves behind isn't its monuments. It's not its machines. It's the mess it makes. Seriously, towers fall. Steel rusts, glass shatters, but chemistry? Chemistry sticks around. Let's put it this way. If some alien archaeologist or future Earthling millions of years from now wanted to find proof that we were here, they wouldn't be looking for our skyscrapers. They'd be digging for our smog. They'd be analyzing the crust to see, hey, why does the carbon suddenly spike in this layer? Why is there plastic embedded in rock? Why do we see chemical signatures here that don't show up anywhere else in Earth's natural history? Because here's the thing. Every time we pull something from deep underground, fossil fuels, rare metals, minerals, and burn it, process it, or throw it away, we change the chemistry of the planet. Not just now, forever. Start with the atmosphere. When we burn coal, oil, and gas, we're not just making smoke. We're changing the air itself. Carbon dioxide levels rise, methane leaks out, nitrogen oxides, sulfur compounds, aerosols, all that gets dumped skyward. Now, Earth's had carbon spikes before. We talked about that. But when you throw in the isotopic fingerprints, like more carbon-12 than carbon-13, you start seeing something odd, something unnatural. It's like the difference between smoke from a forest fire and smoke from a plastic factory. Same haze, different origin. Then there's the soil. You'd think dirt is just dirt, right? But oh no, dirt remembers. When we mine, when we farm industrially, when we dump waste, we change the structure of the land. Heavy metals like lead, mercury, cadmium start piling up. Synthetic fertilizers alter nitrogen ratios. We even leave behind stuff that doesn't belong in soil, like microplastics, PCBs, and Teflon. You can peel back the layers of the earth like pages in a diary, and at some point the story starts screaming, humans were here. Now, let's talk about sediment. Every year, rivers carry mud, sand, debris downstream. That stuff settles, layer by layer. Quiet, patient, permanent. But when we interfere, when we build dams, strip forests, dump chemicals, the sediment changes. Instead of just natural silt, we start seeing industrial waste, fly ash from coal plants, slag from smelters, tiny glass beads from road paint, fragments of concrete and rebar washed into rivers. And when that hardens over millions of years, it becomes geologic memory. Here's the crazy part. Even our invisible actions get locked in time. Take fuel combustion. It seems so clean, right? But the combustion process leaves behind a signature. Tiny amounts of stuff that fall back to Earth. Soot particles, unburned hydrocarbons, heavy metal ash. They mix with rain, sink into dirt, get buried, and there in some future core sample, they'll be found. A strange little band of chemical weirdness. That band might say, once upon a time, something intelligent burned the planet's ancient energy stores and left behind this scar. Even the ocean isn't safe. All those pollutants we send down the drain, they don't vanish. Plastic bits settle onto the seafloor. Toxic sludge gets trapped in ocean trenches. Industrial chemicals bind to marine clay. And deep underwater, away from erosion, wind, and sun, they can sit undisturbed for eons. One day, a core sample from the Pacific might show a sudden appearance of plastic polymers, artificial hormones, rare earth elements, traces of tritium from nuclear testing, and someone, some future scientist, will say, this wasn't natural. Something made this. So here's the takeaway. If a civilization wants to be remembered, not in myths, not in ruins, but in rock, in chemistry, all it has to do is extract, burn, dump, and repeat. It doesn't have to build monuments. It just has to live like us. Because every factory that belches smoke, every barrel of oil that gets burned, every ton of fertilizer dumped on crops, that's not just pollution. That's geologic legacy. And if we're leaving behind all these signals, who's to say someone before us didn't?
Maybe we just haven't dug deep enough. Maybe we haven't recognized the fingerprints. Maybe we keep mistaking artificial scars for natural ones. That's the core of the Silurian hypothesis. Not that a lost civilization had iPhones or space travel, but that they left behind chemical clues, and we've been standing on top of them all along.
The Anthropocene. Our current civilization's impact is being written into the geological record. Let's take a step back. Forget ancient civilizations for a second. Let's talk about us. You, me, right now. Because if you really want to know what kind of fingerprints a civilization leaves behind, look around. We're doing it. Right now. At full speed. This era we're living in, geologists have a name for it, the Anthropocene. It means the age of humans, a period when human activity is the dominant force shaping the Earth's systems. Think about that for a moment. Not volcanoes, not asteroid impacts. Us. We've become a geological force. And the crazy part? We're leaving a record, a physical, chemical record, written right into the crust of the planet. It's not subtle. You can find plastics embedded in layers of beach sand, microplastics drifting in the deepest ocean trenches, tiny fragments floating in Arctic snow. You can dig into soil and find concrete, asphalt, metal alloys, and chemicals nature never created. You can test ancient air bubbles trapped in polar ice and detect a massive rise in CO2, a spike that lines up perfectly with the Industrial Revolution. You can find radioactive isotopes like plutonium-239 in layers of Earth across the globe, a clear signature of nuclear testing from the mid-20th century. And it's not just materials. We've altered the nitrogen cycle, the carbon cycle, the water cycle. We've rerouted rivers, built dams, flattened mountains, drained wetlands, expanded deserts. We've driven thousands of species to extinction. We've created entirely new ecosystems, urban jungles, artificial lakes, plastic-filled coastlines. And it's all being preserved, bit by bit, layer by layer. Sediment doesn't lie. Future geologists, if there are any, will be able to dig down and read this like a book. Ah, yes, they'll say. Here's the early 20th century, coal ash, soot, leaded gasoline residues. Here's the 1950s, radioactive isotopes from nuclear detonations. Here's the 2000s, microplastics and climate records. Here's when the glaciers started shrinking fast. Here's when coral reefs began to die off. Page after page. They won't need our skyscrapers. They won't need our photos or history books. The Earth itself is writing our story. So when we ask, would an ancient civilization leave a record behind? We don't need to guess. We don't need to imagine. We just need to look at what we're doing now. Because we're doing it. We're burning our mark on the planet. And the question becomes, if we vanish tomorrow, what would survive? Not your house, not your car, not even your bones, but the plastic in the soil, the carbon in the air, the radioactive dust in the rocks. Those would remain. And here's the twist. If we're leaving all this behind without even trying, what might another civilization have left behind, if they ever existed? Would we even recognize their fingerprints? Or would we dismiss them as natural anomalies, just strange chemistry we can't explain? That's the power of the Anthropocene. It teaches us not just about us, but about how any civilization might show up in the Earth's memory. Signs include ocean plastics, concrete in soil, atmospheric nitrogen, radioactive isotopes from nuclear tests. Let's talk about the evidence, Not theories, not speculation, real physical stuff. If a future civilization ever digs into the Earth's crust and asks, "Was anyone here before us?" here's what they'll find. They won't need to look far, because we've already left them a trail. Not breadcrumbs, but plastic crumbs. First, ocean plastics. Our oceans have become a plastic archive. Microplastics are everywhere, floating on the surface, sinking into the seabed, stuck in the bellies of fish. There are literal plastic fossils now, materials called plastiglomerates, a mix of melted plastic, sand, and shells fused together. It's not natural. It's our invention, and it's locked into rocks. Hundreds, maybe thousands of years from now, someone will crack open a cliffside and find a layer of sand with blue plastic specks in it. That's not biology. That's industry. Second, concrete in soil. Concrete, one of our most used human materials. It's not rare, it's everywhere. Sidewalks, skyscrapers, dams, foundations, highways. What's wild? Even after buildings crumble, the dust remains. Crushed concrete leaves behind a mineral signature, a chemical mix of limestone, clay, and additives that doesn't exist in nature. In the soil, this becomes a permanent record. It's as if the planet says, someone was here and they knew how to make stone with purpose. Third, nitrogen in the atmosphere. Now let's look up, not at the stars, at the air. Humanity has radically changed the nitrogen cycle, mostly through industrial agriculture. We've dumped so much nitrogen into the environment through fertilizers that it's shifted the chemical makeup of ecosystems around the world. Plants have changed, soil bacteria have changed, even algae blooms in the ocean have changed. And when scientists dig into ice cores and sediment layers centuries from now, they'll see a spike in nitrogen compounds, a moment in history when nature got overwhelmed by artificial growth. It's not just farming, it's a chemical footprint of a civilization trying to feed billions and altering the planet to do it. Fourth, radioactive isotopes. Here's the smoking gun. In the mid-20th century, we started testing nuclear weapons, and those tests left behind a unique chemical signature, radioactive isotopes like plutonium-239, cesium-137, and strontium-90. These elements don't occur naturally, and they don't go away quickly. Plutonium-239 has a half-life of over 24,000 years. It will still be measurable in sediment layers tens of thousands of years from now. So imagine this. Future geologists dig into a hillside and hit a radioactive layer. They might say, something big happened here. Not a volcano, not a meteor, something intelligent, something deliberate. Because nuclear isotopes are like a neon sign in the dirt that says, civilization happened. All four signs, plastic, concrete, nitrogen, and radiation, are not just markers of our presence. They're hard proof. They're things we've added to the Earth that nature didn't create and can't easily erase. So when people ask, how would we know if a civilization had existed millions of years ago? The answer is simple. We'd look for signs like these, because we're making them right now. Unmistakable, undeniable, unnatural.
The fossil record of the future. What will aliens, or Earthlings, millions of years from now, actually find? Imagine a future geologist. Not a human. Maybe not even a life form we'd recognize. It could be a descendant of crows, or octopuses, or machines that outlived their creators. They're digging through layers of Earth, just like we dig for trilobites, for ammonites, for dinosaur bones. And then they hit something strange. A band of rock, rich in weird carbon signatures. Microplastics embedded like confetti in sediment. Heavy metals unnaturally clustered. Isotopes that don't occur naturally. Something clearly happened here. But what? Our legacy is not what we think. We like to imagine we'll be remembered for our cities, our art, our philosophies. But those things don't fossilize. The Eiffel Tower won't last. Neither will smartphones, libraries, or hard drives. The Mona Lisa? Gone. What survives isn't what we designed to endure, but what we never intended to leave behind. Plastic is the modern fossil. It's not marble statues or steel buildings that define our age geologically. It's plastic. It won't rot. It won't dissolve. It breaks down into smaller and smaller pieces, but it never goes away. Millions of years from now, microscopic fragments of water bottles and grocery bags will still be sitting in the dirt. That's our fingerprint. And radiation rings the bell. Our nuclear tests in the 20th century left a thin ring of isotopes across the entire planet. Cesium-137, plutonium-244, things that don't exist in nature. To any future scientist, that thin radioactive line says something intelligent was here. Concrete is the new rock. It seems mundane, but geologically, it's weird. It's a man-made rock. It has no biological origin. It forms in ways nature never replicates. And we've poured it into every corner of the planet. Future geologists might dig through ancient seabeds and find entire reefs of highways, underground garages, and foundation slabs. Not the buildings themselves, just the ghost of their base. Bones in the wrong places. One of the weirdest things about the Anthropocene is how many animals we moved around. We transported cows, rats, dogs, pigeons, pigs to every continent. So a future scientist might notice, why are bovine bones on every landmass? Why did canines outnumber wolves? Why did coral die suddenly and forests vanish in patches? It's a pattern, but not one nature made. The strange spike of carbon. Then there's the carbon spike. Right around the 21st century, CO2 levels shoot up unnaturally fast. Faster than any known volcano, faster than asteroid strikes. It's a signature of combustion. Fossil fuels burned en masse. It leaves a specific isotopic fingerprint. Less carbon-13, more carbon-12. This alone is enough for any geologist to ask, what happened here? The scar that stays. Geological time doesn't remember everything, but it remembers scars. Just like the asteroid impact that ended the dinosaurs left a global layer of iridium, we're leaving a chemical scar. A line that says, this was no accident. Something conscious was here. If someone finds us, now let's flip the script. What if someone or something finds Earth 1,000,000 years from now? Would they know about Shakespeare? Would they understand democracy, jazz, or memes? No. But they might see an unusual concentration of nitrogen in ancient soils, artificial metals fused into rock, a spike of radiation, fossilized plastic particles, the rapid disappearance of thousands of species, and they might wonder, Was this a turning point or a dead end? Was this the first spark of interstellar life or just another failed match? What kind of ancestors are we? That's the question, isn't it? If we're found, what story do we leave behind? Do we look like gods? Fools? Children playing with matches? Or just one more experiment the universe forgot?
The limits of detection. Why even advanced civilizations might leave nothing behind. We like to think we'd know that if a civilization rose and fell millions of years ago, we'd find their cities, their tools, their satellites, something. But what if the universe doesn't work that way? What if it's not about what was built, but how long anything can last? Let's get real. Even our most advanced creations are fragile. A smartphone, the peak of modern design, becomes garbage in 5 years. A car rusts out in 20. A skyscraper, without maintenance, a ruin in 200. A nuclear reactor, maybe 10,000 years under perfect conditions. But millions of years? That's not just time, that's geological war. So here's the uncomfortable truth. Even we might not leave behind anything recognizable. We think we'll be remembered by our monuments, our machines, our noise. But we might only be remembered by what we didn't mean to leave behind. Our waste, our carbon, our damage. That's the paradox. The more advanced civilization is, the less permanent its fingerprints may become. Why? Because advancement often means efficiency, miniaturization, reduction, integration with nature. Imagine a civilization that doesn't build with steel and concrete, but with biology, living systems, biodegradable tools, self-healing materials. Things that vanish on purpose. Not because they're weak, but because they're wise. In that case, what would be left? Not pyramids, not ruins, maybe a blip in the isotope record, a subtle trace in the carbon cycle, a layer of molecules that doesn't quite belong. But those signals are faint, easily missed, easily explained away. Volcano? Maybe. Meteor impact? Possibly. Industrial age from an ancient species? Unlikely. Not because it's impossible, but because it's inconvenient to believe. We have to face a strange possibility. Maybe we're not equipped to find what we're looking for. Not technologically, psychologically. Because detection isn't just about tools, it's about mindset. And right now, our minds are trained to look for what we would leave behind, not what they would. So we sift through rocks, looking for bones and bricks, while the truth, if it's there, slips by in a cloud of altered nitrogen, a pocket of unusual clay, a whisper in the sediment. This is not failure. It's a test. It's asking, can we imagine something that doesn't look like us? Because maybe the most intelligent species don't leave marks at all. Maybe the ones that truly master their world learn how to blend into it, not rise above it. Maybe they erase themselves gently, like waves smoothing out footprints in the sand. And if that's the case, then maybe we've already found the traces. We just didn't recognize them because we were looking for noise, and they left us silence. Lessons in silence. What the rocks don't say. Sometimes the loudest truths are whispered, not shouted, not carved in stone, just left behind in silence. Because here's the thing about Earth. It doesn't talk. It doesn't explain. It just records. And over time, even those records fade. We dig into the dirt. We drill into ice. We measure gases, isotopes, fossils. And sometimes all we find is a void. No signs, no signals, just layers of stone that say, something happened here. We're just not sure what. It's like trying to read a book after half the pages have burned. This silence isn't meaningless. It's a kind of answer. Not the one we wanted, but one we need to respect. Because silence tells us two things. The past is fragile. So is the future. Let's be honest. We want the universe to make sense. We want patterns, stories, order. But Earth? She doesn't care about our narratives. She buries things, melts things, crushes, folds, and reuses everything. It's not personal. It's just geology. So when we stare into ancient rock and see nothing, that doesn't mean no one was there. It might just mean they didn't leave much, or we're not looking right, or time simply washed it all away. This is where humility kicks in. Because maybe we're not the peak. Maybe we're not the first. Maybe we're just next. Another line in the strata, another layer in the dirt. We want to believe we're permanent, but we're not. And the silence reminds us. Still, we keep asking, because that's what humans do. We're not built for stillness. We're built for questions. Big, annoying, impossible ones. Like, are we alone? Are we first? Will anything we make actually last? We may never get answers, but asking still matters. Why? Because curiosity is what got us here. It's what builds telescopes, launches satellites, digs holes in Antarctica, and wonders about civilizations that may never be found. Curiosity is a form of hope. And humility, that's our grounding wire. It reminds us that even if we are the first, we might not be the last. And if someone follows us, what will they see? What will we leave behind? A message? Or just mess? So here's the deal. Silence isn't defeat. It's an invitation to wonder, to imagine, to learn. It asks, can you sit with not knowing? Can you keep searching, not for certainty, but for insight? Because sometimes the most important thing isn't what you find, it's how you look. In the end, we may never uncover a single ancient skyscraper. No lost texts, no alien blueprints. Just hints.
just questions. Just the quiet murmur of a world that's seen everything and keeps it to itself. So listen closely, not just to the noise, but to the quiet, to the gaps, to the layers between the layers. Because sometimes the most human thing we can do is wonder what came before us and who might come after.